All right, everyone. Sorry for the slightly different look to this lecture. I've been making a couple of revisions to this class. I'm still not quite done with it, but I wanted to make sure that we had all of the content that you guys need to learn built into this class. Future iterations, I'll make sure all the videos look nice and clean, but for right now, we're in the middle of reprocessing this thing, so I apologize, but you're still going to get all the content that you need. That said, I wanted to introduce you to a couple of really important design considerations that you should have in mind. Some of these considerations are going to be important, especially in the roles that you guys are working in. Some of them might be adjacent to the roles that you're working in. Some of them you may never even need to consider. But a lot of these are still very, very important concepts. And I want to walk you through them because they're going to be important context that you'll need as we go through this class. So today's agenda, I want to talk to you guys a little bit about native versus output files, sort of the files that we work in versus the files that we send to the clients, essentially, is another way that you could say that. We'll talk a little bit about file compression, and that's really important because there are different types of compression, and it's sort of important that you know what the different types are. It is a little bit correlative to native versus output file, so it kind of makes sense to throw into this one. Technically, these could be entirely separate classes of their own, so we're really only going to scratch the surface on these, but types of printing. This is extremely technical. I'm going to be very upfront with you guys and just let you know this lecture is, it can get confusing. There are a lot of things that I'm going to throw at you. Some of it's going to be very technical. Some of it can be really hard to understand. So if you have questions, I encourage you to reach out. They're important questions. I don't expect you to sort of retain this all on the first pass. I want to be very upfront about that. This has taken me years to learn. I remember when I first started in the industry being very confused about printing, even though that was literally what I went to school for. So be kind to yourself with this one. We'll also talk about color. That's going to be hugely important no matter what role in the design industry you ultimately go into or intend to specialize in. If you're a UX designer, you need to know about color. If you are a print designer, you need to know about color. If you are a video and motion graphics designer, you need to know about color. If you're a photographer, you need to know about color. Color is one of the single most important things that we deal with in this industry, and it's important that you know it. So just get ready. And because this lecture is extremely technical, I would imagine I'm going to cross a few wires for you guys on this one. I also want to talk about imposter syndrome and sort of leveraging your network of peers as you guys are here at ASU. So we'll get into all of that today. So first, let's start with native versus output files. And this section is critical because it sets up various file types and how you should organize, save, and deliver your work for the rest of your careers going forward. Now, different companies may approach what I'm going to tell you here a little bit differently from one organization to the next. But by and large, they're all following some very similar concepts as what I'm telling you here. And file output and naming is a really, really, really important topic. It's actually a huge deal, especially when you're working on a creative team. First, if you deliver the wrong file type, it could cost your company a huge amount of money, believe it or not. I've done it. I think every designer has a horror story of sending the wrong file to the client. It's a big deal. Sending a JPEG to print versus a PDF could cause an absolutely huge production issue as well. And then additionally, file naming is critical because you likely aren't going to be the only person who needs to work on these files. Multiple people on your design team need to know where your files are and how to access them and they're going to need to be able to work in them as well. So this section is designed to save you countless headaches when a client asks for revisions 6 months later, or when they need to update a logo for a new application, or really this is just important information for you to be able to work on a team. Very simply, native files are editable. That's a great way to look at them. Output files, on the other hand, are generally thought of as finished products or client-ready files. And when you work in Illustrator, InDesign, Photoshop, apps like that, everything is still live. That's sort of the term that we use for it. You have layers, you have effects, you have text, all of it can sort of be changed in that environment. But once you export something to a format like a PDF or a JPEG or a PNG, et cetera, there's a lot of different file types. You're essentially flattening everything, and you're flattening it into a new file format that anyone really should be able to open on any device, no matter the software that they have or what they have installed on that device. But from that file alone, you can't really go back and edit the original components from what is called your native file or your working file or your mechanical file. You would have to go back to that native file in order to make those edits. Both file types are extremely important. We need both of these. It's not a one or the other conversation. Think about it this way. Your native files are essentially your kitchen. It's maybe a little bit messy in there. There are ingredients everywhere. Pots and pans are out. But on the other hand, the output file is the meal that you're going to send out to your guests and that you're going to serve to your guests. They don't need to see how you made it. They just need it to look good and taste good. In this sense, they need it to look good and work good. Same thing when it comes to design files, right? Clients need to use my analogy, finished meal, but they don't get access to your kitchen. But you will see, and you're still going to need to be able to access your kitchen. You need to be able to access your kitchen, not your client. So again, it's important that you have both. It's not a one or the other situation. So let me be really clear about this. If you don't save your native files, you will absolutely regret it at some point. Just to give you a scenario that happens all the time, you're going to finish a project, you'll export a JPEG or a PDF, you'll send that to the client, and then maybe you delete the PSD file because it's taking up a lot of space on your hard drive, and you were running out of space anyways, and you just want to clean up a little bit. And then 3 weeks later, the client emails and says, hey, can you make that text blue instead of red? Happens all the time. Or maybe it's, can we swap out that photo? And now you're kind of stuck because you have to rebuild the entire design from scratch at that point, because you don't have the original file that it was made in. You just have the exported version. Native files keep everything editable. Your layers remain intact within native files. Your text is still alive and can't be changed. Your effects can still be adjusted. They also give you a lot of quality control. You can export that same native file at different sizes, different resolutions, different formats, and it'll maintain that quality each and every time. Future revisions are pretty much guaranteed in this industry. Clients change their minds constantly. Stakeholders provide feedback sometimes months later. I'm currently working on a few projects where it's been a couple of months since I got feedback, so I'm going to need to know where those files are. Companies end up rebranding. There's a lot of reasons why a client might need to get back to that file. And if you don't have that source file, you're either going to be rebuilding that from the ground up, which is frustrating in an industry where the faster that we're able to work, the more money we're able to make. Or you Might end up having to tell the client that you can't make the change, which is not a great look for you personally. Um, and not only that, but think about your portfolio evolution too. That project, even if you think it's just okay right now, might turn into a really strong case study maybe a year or two from now. Maybe the client keeps coming back and they keep editing and revising and all of that stuff. You're going to want to show that journey and that process of those iterations and those changes. So, very important. Keep those native files so that you can revisit and refine and work as you develop as a designer. This is going to feel a little bit counterintuitive to some of you at first because your instinct typically is to be helpful and to give clients everything they ask for. But this actually isn't what we want to do all the time because handing over your working files almost always creates problems down the line. First off, most clients don't even have access to Adobe Creative Cloud or Figma, or they have absolutely no idea how to even open a PSD or an AI file. So they'll send you a dozen emails asking why the file won't open, and now you're spending time playing IT when really just walking them through softwares that they don't have installed or any experience with instead of actually doing design work, which we all want to do. Second, giving away your native files really undermines your value as a designer. If they have your working file, they can essentially make changes themselves, kind of contrary to what I said earlier, but maybe they have a nephew who quote unquote knows Photoshop or can sort of make those changes for you. And they can do that without necessarily hiring you back for those revisions. In a way, that is billable work that you just lost. And then third, it compromises the integrity of your design. Clients will go in, they might change things, they'll probably break things. They might strip out elements that you really carefully took the time to make perfect. And then when it looks bad, other people are maybe going to assume that that's how you originally designed it. Your name is essentially attached to every piece of work that you create, whether people know it or not. Whether you touched that final version or not, your name is still attached to it. And fourth, it creates some real liability issues. If they mess up the file and try to blame you, or if they make unauthorized edits and start distributing altered versions, you've essentially lost control of your own work and potentially your professional reputation as well. Now, there are some legitimate situations where it makes sense to hand over source files, but these need to be very clearly defined in your contract or scope of work before the project even begins. If it's explicitly stated in your agreement that deliverables include native files, then yes, absolutely deliver them. But hopefully you should be charging more for this because you're essentially giving up future revision work and ongoing involvement with that project that could be billable hours. Logo files in vector formats are one of the most common requests that you'll see. And this one actually makes a lot of sense. Clients need to be able to send their logo to print vendors, sign companies, embroidery shops, even other designers. And all of those vendors need vector files to work with. But an SVG or an EPS export in these situations is typically sufficient. They don't always need the full AI file to work with. But an SVG or an EPS file, both of those are typically good. And the reason for that is that they often don't need access to your construction guides, your alternate versions, and all the working notes that you had as you were going through it. So just give them that clean vector format that they need. That's typically more than enough. Um, in other situations, sometimes a large enterprise company and enterprise clients, they often have policies that require them to own all of their creative assets as part of their intellectual property retention and some of their safeguards that they have around their intellectual property. So in those situations, that's fine, but it really needs to be negotiated upfront and reflected in your pricing and the way that you bill that project. Don't just hand over files at the end of the project without having discussed that well beforehand. And if you're handing off a project to another designer, maybe that's someone on your team or an in-house design department at a client organization, then yes, you should probably provide those clean, well-organized native files. Clean them up, make them nice, make sure the layers are all named. That's just being a professional and a good colleague. And if you're considering a career as a freelancer, or even just want to learn more about how to protect yourself with proper contracts and scope of work agreements, you should really think about adding GIT 550 to your IPOS. We cover all of that in that class. Now, file naming is one of those things that seems tedious, maybe even a little bit boring, until you realize how much time and frustration it saves you. A good naming system means you'll never accidentally send an outdated version to a client. You'll never sit there wondering which file is the current one, and you really shouldn't be wasting 20 minutes digging through folders trying to find the project from 6 months ago that you're like, wait, which one was the last one? This structure that I have outlined on this slide works incredibly well. We use a structure very similar to this one at Renneker Studio. And the nice thing about this file naming structure is that it's scalable. It sort of works at scale, no matter how many projects you're managing. First, write the client's name or acronym for the client, something like ASU. Then the date in what is called a 4-digit year. So 2026 would be a 4-digit year, but just 26, that's only a 2-digit year. After that, it's followed by a 2-digit month. So if it's January, you would put 01. And then after that, you would do a two-digit day. So if it's January, let's see, what's the first day of class here? January 12th, we'll say, 2026, you would do 202601 12. And the reason for that specific format is that it will automatically descend based on date. So that helps with the file naming when you're looking at your Finder or your File Explorer. Then after all of the dates, you would put a really very brief, like 1 or 2 word description of what the file actually is. And at the very end, a version number. And that version number is 2 digits separated by a period. And I'll break that down just a little bit further, how versioning works, because this is the part that I think is really, really valuable. And you want to make sure that that version number is at the end so that you can change the file names quickly. Trust me, it saves so much time. But the first digit prior to the period represents how many times you've actually sent the file to the client. Often when an agency bills a client, they typically build out their scope of work with a specified number of revisions. And the reason for that is that it's just a really good way to track those rounds of revisions on any given file, per se. The second digit then represents how many times you yourself as the designer have saved and revisited that file internally since the last time you sent it to the client, because we sometimes will have revisions that we make to a file, and maybe we have internal design review and we need to go and make changes. Between each of those, you're probably making some saves. So if you're looking at a file that says version 2.3, for example, that means it's the second version that you've delivered to the client, and you've made 3 rounds of internal edits or saves since you sent them version 1. This system is really nice because it prevents confusion and creates a very clear paper trail. I've personally had this practice save me during a dispute with clients. It sounds like overkill right now, probably while you're a student, but start creating good habits now. I beg you, because when you are managing 10, 15, even 20 projects simultaneously, which is not uncommon. I think I currently have a workload of about 32 projects sitting on my desk, so it can get a little intense. And then add on top of that, that you've got clients emailing you, say, hey, can we go back to this logo version we talked about in October? And hey, can we try this? And it gets a lot. When all of that's happening, you'll be able to know exactly which file to open in about 5 seconds. It's very, very quick and efficient. And your future self, even just beyond all of that, will absolutely thank you for building this good habit right now. So just get in the practice of doing that. You're going to need to do that in this class. I expect file names to be perfectly accurate to how I've spelled them out in the class. It's a variation of this. It's a little bit different, but it's close. Additionally, file names also need to work across every single platform and system you, your clients, and even future coworkers are going to eventually encounter. Mac computers, PCs, web servers, cloud storage systems, email attachments, content management systems or CMS systems, file transfer protocol servers or FTP servers. All of your files need to work in all of these different scenarios. So it's important that you know about special characters. Special characters cause problems because many of them have specific technical meanings in operating systems and coding languages. Special characters in file names can actually prevent files from uploading. They can break hyperlinks on websites. They can make files unsearchable, or in some cases, they can actually make files completely disappear from directories or corrupt an entire drive full of other files that maybe weren't an issue. So stick to these. I beg of you, please. Only use these standard letters, numbers, hyphens, underscores in your file names. Spaces are technically safe, but depends on the system that you're using. This is sort of your safe zone. Keep your file name simple and boring in terms of characters that you're using. This is really a small habit to build, and it prevents some genuinely catastrophic problems down the line. And I'm speaking from experience there. So please just do yourself a favor, stick to these. Just to give you a quick reference guide, every single character on this list will cause you problems at some point. Ampersands break URLs on websites, colons mess up file path structures, slashes are directory separators. So if you put a slash in a file name, operating systems are thinking that you're trying to create a new folder and your file structure ends up corrupted. Learned that the hard way. Parentheses and brackets confuse some automated scripts, and especially now that we're kind of going into this age of AI where files can run through AI, that's going to become particularly problematic. Asterisks and question marks are sort of what are called wildcard operators, particularly within command lines, and they tell computers to select or delete multiple files at once, which means that one misplaced asterisk could actually wipe out half of an entire project folder or even an entire project folder. Um, and if you're running images or something like that through batch processing, um, sorry to say, but you're screwed. You just destroyed every ounce of data on your hard drive. It's bad. Um, Yep, emojis and fancy Unicode characters. Students always want to try to get creative with these, but they'll completely break file uploads and most file transfer protocol systems. Um, when you're under a deadline at 11 p.m. trying to deliver files to a client and your upload keeps failing because there's an emoji in the file name, you'll wish you had named it something a little bit more boring, trust me. So don't try to get clever or creative with your file names. Be simple, be predictable. Boring file names work 100% of the time, and that is a margin of error I can get behind. Now, I'm sure everyone's seen or even written a few of file names something like this. it I've seen some wild file names in my days. It's sort of become a running joke in the design community because we've all done this at some point. Um, you're under a deadline, you're making frantic last minute changes, and you just need to keep saving new versions without any real system. It happens, but don't do this. You are going to save yourself so much time if you follow the structure that I said before. So much time that you're not going to have to spend going into each of these files trying to figure out what the heck did I do here? What is this thing? The solution to this is really simple. Increment your version numbers consistently. Never overwrite previous versions and just save frequently throughout the process of a project. Don't overwrite your version 1 with new changes. Instead, save those as a new version 2. And disk space these days is incredibly cheap. Your time is, in fact, much more expensive than disk space. So when a client comes back 2 weeks later and says, actually, can we go back to the version that we had in the orange background instead of the blue one? You want to be able to open that exact version in about 10 seconds. So ideally, you're not spending an hour digging through your computer's trash folder or some of these weird and sort of ambiguous file names trying to remember which file had which color scheme. This also presents you and your work so much more professionally to your clients or coworkers. Sometimes it's genuinely the smallest things, the smallest details that make all the difference and make you the designer that everyone wants to work with on the next project. Good version control practices protect your time and make you look incredibly organized and professional to clients. Designers also tend to be hack rats with their files. And honestly, I think that's a really good instinct to have in this industry. Sometimes you'll finish a project and maybe you'll look at it and think it's terrible or embarrassing. And trust me, I've had the instinct too, where you're just like, delete. It's very important that you don't do that, though. First, that project that you think is weak or unpolished right now is just documentation of your growth as a designer. I have students ask me all the time, how many projects should I put into my portfolio? And my answer is always everything. Absolutely everything. Your portfolio should show your entire journey as a designer or a creative. When you're interviewing for jobs 2 or 3 years from now, being able to show where you started versus where you are now is really valuable and actually is one of the first things I look for in a portfolio when I go to hire a designer. I genuinely want to see your journey, not Not that you're a UX designer who is, uh, I don't know, I'm trying to think of something. Uh, a UX designer focused on building thoughtful, human centered experiences through empathy and research. Ugh, yuck. I've read that line, I don't know how many times in this role. Don't do that. Please, for the love of God, don't do that. Second, clients circle back to old ideas constantly. They will reject a concept in February, then email you in August, 2 years later, saying, remember that blue version of the logo that we passed up on? Um, let's come back to that. Let's use that now. If you deleted it, you're going to have to rebuild it from memory, remember the exact color of blue that you used, or hopefully you at least have a low res screenshot laying around somewhere, just sort of trace evidence. It's no fun, but I've been there. So just keep everything. And third, I can't tell you how many times I've mined some of my old work for parts. I actually have a folder on my hard drive called The Graveyard, where I'll put little passion projects that I never finished, or client projects that died before they were finished. And I will reference it sometimes, pretty often actually. I'll go there for color palettes, maybe textures, or a specific technique that I used, or maybe it's just a typography pairing that I thought looked really smart, or um, layout ideas that I've already built from previous projects. Everything that you make in this industry becomes a reference material. And even from there, sometimes work you thought was mediocre becomes a really strong portfolio piece once you've maybe had some distance from it and then reinvested some time into maybe polishing it up a little bit. Again, storage really costs almost nothing now. External hard drives, SSDs, cloud storage, those are all incredibly cheap items. But losing your work and having to recreate it, or missing opportunities because you don't have that file, um, or a example of work that represents the type of work that the client is looking to hire for, if you don't have that anymore, that's incredibly expensive. That could be the difference between you getting the job and losing it. So I cannot encourage enough to save everything, organize it well, and let time decide what's actually valuable and what isn't. All right, I have a few rules for storing your files, and I guarantee you will forget these rules until the moment something bad happens, and you'll come running back to me when it does happen, and you'll tell me that I was right. Believe it or not, it happens all the time. So, rule number one, and I really mean this, do not store files of any kind directly onto your computer, not even temporarily. I'm not trying to be paranoid. This is me having watched way too many students and professionals learn this lesson the hard way, myself included. Computers fail, hard drives crash, laptops get stolen, you spill coffee or water on your keyboard, a power surge from a lightning storm outside fries your motherboard, your dog chews through the hard drive, brother downloaded porn on your computer and corrupted your drive. Folks, I've seen and heard it all more times than I care to have, if I'm being completely honest. Uh, if all your project files are saved locally on your computer's internal hard drive, you are one accident or one technical failure away from losing everything. Your entire portfolio, every student or client project you've ever worked on, years of work, poof. And if you're in one of my classes, I won't shed a single tear for you. Sorry. consider this your warning. So if you're not storing files on your computer, where do they go? Um, let's start with physical external storage and specifically solid state drives or SSDs. Now, the obvious downside here is that a physical hard drive can still technically be lost or stolen. Not even technically. I could walk over and unplug it from your computer and walk out. It's a thing you have to carry around with you. You have to keep track of it. But there are some real advantages that do make them worth considering. First, you own it. That's the beauty of it. You pay once up front, and that storage is yours forever. No monthly subscription fees, no ongoing costs. It's quite nice. Second, you're not dependent on internet connectivity when you use these things. If you're working somewhere with terrible Wi-Fi or no internet at all, you can still access your files instantly. That's kind of the beauty of these. That's why I have an army of them. Third, there's also no privacy concerns about your files sitting on someone else's servers or getting caught up in a data breach. You do have other privacy concerns like viruses and things like that if someone else gets a hold of it, but everything is physically in your possession. It's all under your control. And fourth, your data transfer speeds can be exponentially faster because you're not necessarily bound by your internet's upload and download speeds. Now, if you're going to invest in external storage, you should really strongly consider spending just a little bit of extra money to get what is called a solid state drive. That instead of a traditional spinning hard drive. The difference here is that traditional hard drives have moving parts inside of them. There are actual spinning disks that read and write. Rather, there are spinning disks, and then there is a reading and writing head that writes the data onto those disks, almost like a DVD or a CD, if you're old enough to know what that is. And those spinning items create some risks. If you drop one of those drives, or if you disconnect it without ejecting it properly first, you can corrupt files, you can corrupt the entire drive, and still lose everything on it. So those traditional hard drives are still just as volatile as your desktop hard drive. And it happens constantly. It's happened to me. Whereas on the other hand, SSDs don't have any moving parts. They are solid. It's the solid part of solid state drives. They use what is called flash memory chips instead of those moving parts. So they're way more durable, way more forgiving when you make mistakes or have accidents. It's really, they're quite nice. I personally use an army of a brand called SanDisk Extreme Pro. And those are portable SSDs. I cannot recommend them highly enough. I've been using 4 terabyte SanDisk Extreme Pro portable SSD version 2. Those run about $450 from B&H Photo Video or Amazon right now. I actually just upgraded to an 8 terabyte version of that, which was about $800. So you're running about $100 per terabyte, dollar per gigabyte. Let's see. If the $450 version is stretching your budget a little bit, you can probably get away with stepping down to a 2 terabyte version. Those typically run about $320, or you might even be able to get away with a 1 terabyte version. Those are about $200. I know that sounds like a lot of money. If you're a UX student and most of your work lives in Figma anyways, 1 terabyte is probably plenty. You might not actually need a solid state drive at all. The next option that I'm going to mention is probably going to be perfect for you. But if you're doing a lot of print design, working with video, particularly if you're working with video, or doing photography work with large raw files, you're going to want to spring for the 2 or the 4 terabyte or even a 8 terabyte option. I know that sounds like a lot of money when you're a student, probably eating ramen noodles for breakfast, lunch, and dinner, but think of it as career insurance. Um, you're protecting your years of work and potentially your entire portfolio. Um, Side story, I accidentally washed one of these in the washing machine. I think it was in my pocket after a photo shoot. And I'm talking full laundry cycle, hot water, detergent, the whole deal. I think it even went in the dryer. I pulled it out, let it dry out for a day or two, and plugged it in to see what destruction I might have caused. And it still worked perfectly. Every single file was intact. I still actually use that drive today. Now, obviously, I'm not recommending you test that. Please don't wash your hard drives, but it gives you a little bit of an idea of how much more durable these things are compared to traditional hard drives with moving parts. So if you can swing it financially, get yourself a good solid state drive, a good SSD. Do that now. Build the habit of saving everything to it immediately. And I recommend doing this in combination with my next rule, which is, hang on, there we go. Use cloud storage. It is honestly going to be your best long-term solution. Cloud storage means your files live on remote servers that you can access from anywhere in the world as long as you have an internet connection. And the huge advantage here is that you don't have to physically carry a drive around with you. You don't have to worry about it getting lost or stolen. And you can access your work from your laptop, your desktop, your tablet. I access it from my phone sometimes, or really any device. It doesn't even need to be yours per se. You just need to be able to log in. You also don't have to remember which physical hard drive you stored that info or you saved that information to or that file to. If you end up in a situation like this where you have so many files that the only hard drives that can accommodate it are the size of a school bus, I've run into that. Instead, you can make everything accessible from the same place. Just to give you a few of the main options that exist out there, Google Drive is probably one of the most accessible options to students. It integrates relatively seamlessly with your Google account. You probably already have one. The pricing is extremely reasonable if you happen to go beyond the storage that is provided for free. And the interface is pretty straightforward and easy to use. You get 15 gigabytes of storage for free, and then you can upgrade to the paid tiers when you need more space. The main limitation here, though, is that you will eventually run out of storage space, especially if you're working with a lot of high resolution photos, raster images, or any kind of video files, really. Those eat through storage very quickly, but a lot of UX students whose work probably will live primarily in Figma and whose files tend to be much, much smaller, Google Drive is probably sufficient and affordable. You can even use their extension to be able to access files from your Finder and your File Explorer. Adobe Creative Cloud Storage it comes included with your Creative Cloud subscription. So technically you already have access to it without paying anything extra. But I'm going to be just completely honest with you. The interface is really confusing and clunky. Navigating through your files is frustrating. Oftentimes you may even end up with multiple Adobe accounts, not because of the Creative Cloud storage, but you are obviously going to have a Creative Cloud account here because you're a student at ASU. You may choose after being a student at ASU to purchase your own license to Adobe Creative Cloud, in which case you might transfer that to your personal email, which then your Creative Cloud subscription would go to that, and you can't transfer files that way, or at least I don't think you can. And then if you ultimately get a job, they should be paying for your subscription, and same problem all over again. So it's just frustrating. um, yeah, yeah. Um, Accessing things also take way more steps than it probably should. The interface is just confusing and clunky, and navigating through your files is frustrating. Um, I don't like it. The whole thing just kind of sucks to use. Um, I really don't recommend relying on it as your primary storage solution. It's there if you need it for an emergency or for quick file sharing between Adobe apps, but there's not much better options available. There are so many better cloud storage options. Dropbox is very similar to Google Drive in terms of functionality. It's got a really clean interface. It's got reliable syncing, and you can access it from anywhere, just like most cloud storages. Um, you can also use their extension to access files through your Finder and your File Explorer, though you typically have to download them. Same with Google Drive, even if you are accessing them from your Finder or File Explorer. It works particularly well for collaboration because you can easily share folders with team members or clients, and everyone can kind of see updates in real time. The pricing is very comparable to Google Drive. Dropbox is also extremely scalable. Lots of enterprises use Dropbox. So you'll be investing in a system that is extremely common. It's a solid, super reliable option if you're already using other Dropbox features or if your workplace already uses it. SharePoint. Let's talk about SharePoint for a second. Okay. Some of you are going to end up at companies that will use SharePoint for file management because it's part of the Microsoft Office 365 suite, and a lot of big corporations are completely locked into Microsoft's ecosystem. I'm just going to tell you right now, SharePoint is hot, steaming garbage. It is slow, it's clunky, the folder organization system is completely unintuitive, searching for files is frustrating if you ever find them, and it's just generally unpleasant to work with, in my opinion. But sometimes you aren't going to get a choice in the matter, particularly if that's what your employer has decided everyone has to use. So just know it exists. You might have to deal with it professionally, but for the love of everything good in this world, do not choose it voluntarily if you have literally any other option available to you. SharePoint, sorry, not a fan. Box, however, Box.com, which is what I have shown in this image here, is what we use at Reniker Studio. It is genuinely fantastic. I love it. But I will be upfront and say that it is spendy. I currently pay about $1,300 per year for it, and there are cheaper options, including even a free option. But I do this because Box offers unlimited storage at certain tiers and has a ton of super powerful features that make client collaboration smooth and professional, and it connects with my Finder beautifully in a way where I don't have to download the files like you do in Dropbox or Google. It's really the ultimate file storage option that can sort of scale with you. I currently have about 20 terabytes of files stored in Box Drive. It's amazing. They're all in there right now. We're talking hundreds of thousands of raw image files. There's PSDs in there, JPEGs, some video content, tons of vector files, all of it. And the only reason I'm paying so much is so that I can have multiple employees with their own logins to have access to the drive at one time, as well as being able to upload up to 15 gigabyte files at one time, which is massive. So the really big advantage of us being able to use this is that we can access absolutely everything from anywhere in the world without having to think about file sizes or how much storage we have left before we need to upgrade to a tier and ultimately pay more, or which hard drive something might be stored on, or whether I have the right drive with me. Uh, while they have some individual pricing plans, Box's pricing, at least at the higher tiers that we're using at Reniker Studio, is really geared towards businesses, agencies, studios, not so much towards individual designers or certainly students. But if you plan to eventually run your own studio or you're working at a company that can expense it, Box is an excellent choice. I highly recommend it. It is extremely scalable, and I would recommend it to anyone. But for most of you who are just starting out, might be a little bit overkill unless you're using one of like the free versions. All right, bottom line here. Pick a cloud storage solution that fits your budget, your workflow, set it up properly, and then actually use it. Use it consistently too. Don't fall into the trap of saving things locally with vague information or vague intentions of uploading them to the cloud later. Later never happens. And then your laptop gets stolen, your hard drive fails, and suddenly later is too late. Build the habit now of saving directly to cloud storage as your primary workspace, or at the very least, to an external hard drive, hopefully with a few backups. And you will just save yourself an enormous amount of stress and potential disaster down the road. From there, folder structures need to also be scalable, meaning that what works when you have 5 projects also needs to work when you have 50 projects or 500 projects. Trust me, you'll get there. Trust me. This example structure works really well. We use a similar but slightly different version of it at the studio. You have individual deliverable folders. Let me start at the top, actually. First, you start with your projects. Then inside that folder, you create a folder for each client. Then inside each client folder, you have individual deliverable folders. And inside each deliverable folder, you have subfolders for assets. Assets are generally just references that the client gives you, or individual assets, things like images, copy documents, icons, illustrations, color palettes, etc. Things that you will be using to build your working files. Then you set up another folder for client files where you will put things like your JPEGs, your PDFs, your PNGs, etc. And then you also have a folder for your working files where you put your native mechanical files, things like your Illustrator files, your Photoshop files, InDesign files, etc. This just helps keep everything organized and makes it really easy to find what you need, especially when every project looks exactly the same and the structure is the same. You know where to go in this. Now, you can absolutely adapt this to whatever makes sense for your brain and your workflow. Some people organize it by year, some by project type, some by client. Those are all fine approaches. Because the key here isn't do exactly as I say, it is be consistent. Personally, I like to ensure that my client and working files are no more than 2 folders deep, because extra clicks add up. And I go to the chiropractor twice a week because carpal tunnel is a bitch. So know that that's a thing. Also, I'm going to stop sharing my screen for a second. You should immediately go to your local office supply store or Amazon and look for these. This is a mouse pad with a built-in wrist rest. It's padded, very helpful. Jamming we all like to use our mice, and that produces, I'm a bad example. Work with a more ergonomic mouse. I am married to this thing because I've used it for 20 years. Um, get yourself a more ergonomic mouse. Start now. Don't be like me. But jamming your wrist onto the table all day, or God forbid you use a trackpad, you are going to jack up your hands. And our hands are how we make money in this industry. We need to be able to be dextal with our hands. So just really save yourself. This is maybe between the two of these, $40 on the high end if you're buying really nice ones. Mine is falling apart, so I'm due for a new one. Do this. Save yourself. I beg you. All right, back to it. So, where was I? We were talking about file structures. Personally, I like to keep my folders. No, I like to keep my working files no more than 2 folders deep. At the end of the day, just pick a folder structure and use it for every single project. No exceptions. 3 years from now, when you need to dig up a file from an old project, you really shouldn't have to think about it for much longer than 2 seconds. Yeah, you won't need to search through a dozen random folders. You should know exactly where to look because you've used the same organizational system every single time. You should be able to have your 70-year-old grandma pick up your computer, and you should be able to give her some instructions for where to find that file. And it should be exactly where your grandma is looking. Choose your structure, commit to it completely, and stick with it forever. That's the big deal. It will save you hours of frustration over the course of your career. Trust me. All right. Every single designer you will ever meet has a horror story about losing files. Their hard drive crashed without warning. Their laptop was stolen from a coffee shop. They spilled an entire glass of water on their computer. They corrupted a file that couldn't be recovered. Power surge fried everything. It happens to everyone eventually. And if you haven't prepared for it, it is absolutely devastating. The design industry is not like other industries where a even very nice resume gets you the job. Your portfolio, your files, your work is your access point to this entire industry. It's how you get jobs, how you land clients, how you prove that you're capable of doing the work the company is hiring you for. If you lose those files, if you lose your work, lose your case studies, you lose your proof. You lose your ability to show potential employers or clients what you can actually do, what you're capable of. One accident, one spilled drink, one technical failure should not be able to end your design career or set you back years of work product. But it will happen if everything is sitting unprotected on your desktop or on a thumb drive with no backup. So save everything. Save early, save often, back your work up frequently, or better yet, use cloud storage. Use external drives when the time calls for it and build redundancy into that system so that you have multiple copies in multiple locations. I promise you, this is not overkill and it is not paranoia. Okay, maybe it's a little bit of paranoia, but more than that, really, this is just professional survival. You need to take this seriously now before you learn this lesson the more expensive way, and honestly, the more painful way. Protect your work like your career depends on it, because it genuinely does. Very serious about that. All right. File compression. This section is all about understanding the different ways that files can be compressed and when to use each type. This might seem technical, but it's actually pretty straightforward once you understand the basics and start using the softwares we're going to be talking about in this next section. But it's important to know that making the wrong choice here, like sending a JPEG to print, or when they need a PDF, let me rephrase that. If you send a JPEG to print when they actually need a PDF, it can cost you some real money, and it can cause production delays, and ultimately it lands at the client late. There are so many issues that can be caused by sending the wrong file. So pay attention to this section because it'll save you from some really expensive mistakes down the road. Compression is basically about choosing what data to keep and what data to throw away, or how to essentially reorganize data more efficiently, particularly when you're saving a file. Every single time you export something, whether it's an image, a video, or a document, you are making decisions about compression, even if you don't realize it. There are essentially three main types of compression, though you, as a designer, specifically a designer, are probably only going to have to worry about two of those, but I think it's important that you know about all three. Uncompressed files keep everything. Pretty simple. Lossless files reorganize the data without losing anything. We'll get to that in a minute because that gets a little confusing. And then lossy files are removing data and permanently deleting it to help make file sizes smaller. And understanding which one to use and when to use them is absolutely mission critical to maintaining quality while keeping your file sizes somewhat manageable. Now, I know what you might be thinking. If compressed files give you perfect quality, why not just keep everything uncompressed? And the simple answer here is that it's just not practical. In contrast to what I said in the previous section, storage space does add up and fast. So a single uncompressed raw photo can be 50 to 100 megabytes. And if you're storing hundreds or thousands of images, you're looking at potentially terabytes of storage. I personally have 20 terabytes of raw photos. And beyond that, though, transfer speeds also matter. Nobody wants to wait 20 to 30 minutes for a file to upload or download. There's also platform limitations. Email attachments usually cap out at about 25 megabytes. And many submission systems, like if you have to upload an image to a site, have some strict file size limits also. And honestly, a lot of computers can't really handle some of the more massive uncompressed files without genuinely slowing down or even crashing the computer. So your goal as a designer is to use the right amount of compression for the job. Ideally, no more, no less. This slide shows you the full range of compression options from smallest file size to largest. On the left, you have lossy compression, and these produce the smallest files with reduced quality, but still perfectly acceptable for certain digital applications and some low-end print production. But the trade-off for the smaller file size is that the file will then permanently delete data. It doesn't absolutely need in order to render the content properly. You'll be using these daily as a creative professional. In the middle is lossless compression, which offers moderate file sizes, but still delivers maximum quality output with zero data loss. You'll also be using these daily as a creative professional. On the right are uncompressed files, the largest file types. And often these are very specific file types that you're probably never going to touch. These are things like raw images, log or uncompressed video or audio files. And the reason that those are so big is because they retain additional information that's simply what is shown. You might see something, but there is still additional data kind of sitting outside. I mean, they're still in the file, but outside the visible look of that file. that can still be accessed and used to modify that file. For example, more advanced camera sensors are capable of capturing very minute details in dark shadows and bright highlights of an image. And while you may not be able to see that information in the image's preview, that data is still present within the file and can be accessed and enhanced using platforms like Adobe Lightroom, Adobe Camera Raw, and Capture One Pro. For images in Premiere Pro or Adobe SpeedGrade for video, those are just some ways that you can adjust and bring out more detail within a uncompressed file. But those use very specific softwares that, as designers, we may not necessarily need to access. Now, you can apply a much similar logic to audio files as well, but instead of working with light or photons, you're working with sound waves. And without getting overly technical and into quantum physics debates on the difference between a particle and a wave, I'm going to leave that right there for now. We're going to cross that bridge in just another couple of sections. We'll do that in this lecture, but we'll get there. The important things to remember about uncompressed files is that while they are the largest file size, and still they still offer maximum quality. That's kind of the nice thing about them. These sizes, though, are massive. They are absolutely massive because they are still holding on to all of that excess data, mostly so that photographers and video and audio editors can make their lighting adjustments and audio adjustments before they export them to a lossless file type that us designers can use a bit more manageably. And unless you plan on doing some photo, video, or audio production work, your design role, which I also do, there's nothing wrong with that. I'm a huge photography buff myself, but unless you're doing that photo, video, and audio work alongside your design role, then you'll likely never be touching any uncompressed files ever. So it's good to know that they're there, but you may not ever use them. That said, I'm still going to tell you a little bit about them because if you're anything like me, when I was in school, I still wanted to learn the things that I was told I would never use, mostly because I wanted to be able to work alongside and hold conversations with my collaborating partners and actually know what I was talking about. So uncompressed files are actually what they sound like. Every single piece of data, zero compression applied. The advantages to this are that uncompressed files provide maximum quality, no processing or rendering times, and they give direct access to all the data that was captured. The disadvantages are that uncompressed files create absolutely huge file sizes. They can slow down transfers, and they require massive storage requirements. This is the primary reason why my box drive is currently at 20 terabytes. I have hundreds of thousands of raw files stored on there. Some common uncompressed file types, though certainly not all of them, include WAV and AIFF for audio files. Raw files from cameras come in a lot of different formats. Each camera manufacturer actually has a different file extension for their version of raw files. TIFFs can get a little bit tricky because you can save them as uncompressed, lossless, and lossy versions. They actually come with their own unique compression options baked in. But if you save TIFF files without compression, that obviously makes them uncompressed. And then you have to also have uncompressed AVI files, which can be several dozen gigabytes in size per each individual file. based on recording length, color bit sampling, and sometimes they even include audio within them, etc. They are quite large files that are typically used in non-consumer grade cameras. These are highly professional workflows here. I've actually never personally worked with an AVI file, but they are out there, still very common. You'll typically use uncompressed when you need absolute maximum quality, like when you're archiving professional photography or doing audio mastering. But honestly, most designers won't work with fully uncompressed files very often, except for maybe raw photos straight from a camera. But even then, that often falls far outside the purview of a designer. And instead, the photographer editor will typically provide you with a TIFF or a PDF file for artwork production. Lossless compression is another file type that reorganizes data much more efficiently without necessarily throwing much away. These don't necessarily work like uncompressed files in that they are not a replacement for them. However, you can open, edit, and save these files repeatedly without losing any quality, which is an important difference between lossless and lossy files. As I already mentioned, the file sizes are much smaller than uncompressed, but larger than lossy. Some of the advantages to lossless compression is that you can maintain maximum quality in your files, but they will be much more manageable than uncompressed files, and you can edit and resave them without any degradation or loss of information. Some of the more disadvantages, however, is that lossless files are still much larger than lossy formats, making them not as friendly for sharing with clients and much slower to upload than lossy files. Additionally, some formats like Photoshop files and Illustrator and InDesign files, just to name a few, require specific softwares to open them. Most of your clients probably are not going to have access to their softwares. That's why they've hired you. And then some, but certainly not all of the common lossless file types include PNGs for web graphics with transparency, though this gets a little bit tricky. So I've added a little warning to it. I'm going to come back to that at the end of this section. PSDs for mechanical, primarily raster-based images or image files. You have AIs primarily for vector-based image files, though both Photoshop and Illustrator can work with both raster and vector-based images. That's why I kind of paused there for a minute. So be careful with that. We'll get there. Don't worry. And then you have InDesign for InDesign documents, INDD for InDesign documents, which is predominantly a print publication tool where text and images come together. Technically, you could also put PDFs with print settings applied in here too, but that also gets tricky. So I'll cover that at the end of this section as well. You'll use lossless when quality of your image really can't be compromised. When you need transparency or alpha channels, when you're still actively working on the file and need to be able to retain editability, or when you want smaller files than uncompressed but need maximum quality, though they're not genuine substitutes for uncompressed file types. They're all separate. These are not exchangeable for each other. You should be keeping all of it. And then lossy compression, which permanently removes data to help create much smaller file sizes. Once you save it, you can't get that data back. And every time you resave or re-export a lossy file from an already existing lossy file, not necessarily a lossless file, you end up losing more quality. It sort of compounds as you do more and more with it. And the advantages of lossy files are that they are the smallest possible file sizes with the fastest upload and download speeds. And they have largely universal compatibility. JPEGs are able to be opened anywhere. But that does come with some really big trade-offs and disadvantages. Namely, you get permanent loss of quality that you can't undo unless you have the original lossless file. Um, Lossless files are all, excuse me, lossy files are all raster or pixel based images. And due to this, while you could still open a lossy file in Photoshop, you cannot add pixels where pixels don't exist. So you can't upscale it. There will be little to no data available in the highlights, shadows, or color bit depth for you to make any sort of meaningful adjustments or big edits without introducing some artifacts to that image. Essentially, what you see is what you get with lossy files. Unless you want to make that image smaller, this is inherently and technically possible, though it would still be best practice to return to the original lossless file and just export a new version if you have the ability to do that. Additionally, if you try to open a lossy file and resave it, the quality of the image will degrade with each save. And generally speaking, lossless files are typically not suitable for print or professional archival work because of the previously mentioned reasons, but also because they typically are not capable of holding the correct color space for professional print output. There are some notable exceptions to this. However, if you're a photographer, happen to be printing on an inkjet digital press, many inkjet printers or printing labs may ask you to submit your files using RGB color space rather than CMYK color space. And that's because most professional inkjet printers have anywhere from 7 to 13 different colored inks. Those different ink wells are called print heads, or sometimes they'll still call them wells, but those 7 to 13 different print heads will give digital printers a much larger color gamut than what can be achieved with just cyan, magenta, yellow, and black inks alone. And in this case, a JPEG is somewhat acceptable since a JPEG is primarily a digital web image file type, and therefore its default color space is RGB. But even with all of that said, a TIFF or a PSD file set to RGB color space would still be a much preferred option for that delivery if that printer allows that. Again, that gets really, really deep into color metrology, so I'll leave that there for right now. We'll just circle back to that when we get to the color section. So if you want to learn more about printing and color metrology, though, look into taking packaging design and engineering on your iPods. I'm currently working on developing it, so we should hopefully have it listed in class search by the spring of 2027. Anyhow, some common lossy file types include JPEG for web photos, MP3 for audio, MP4 for video, GIF for sample, very small animations, also with limited colors, interestingly. And then WebPs as a more slightly modern web image format that offers a little bit of added security and reduced image sizes, but also gives us much faster loading speeds from JPEGs. And you should really use lossy when file size matters more than perfect image quality, or when you need really broad compatibility so that anyone can see the image. And also when you're delivering final outputs to clients, these are often the output types that they're expecting. Um, and you can use these when the degree of quality loss is less or won't be noticed by the end user or the end viewer. This table gives you a quick reference for comparing all three comparison types side by side. I'm not going to spend too long here just because we already covered all of this, but it's here for you to reference. And additionally, here's another set of diagrams just showing you an example of a correct versus an incorrect image editing workflow. This is where students mess up all the time. In the proper workflow, you would import your raw image, export it to a PSD or a TIFF, which is lossless, make all your edits and resave as a PSD or a TIFF. Then you would, once you're completely done, you can export from your PSD or your TIFF file to a JPEG or a PNG for use on the web or digital products, or use PSD or TIFF files to send it to print, either way. What you don't want to do is import your raw image, immediately save it as a JPEG, make edits to that JPEG, save it as a JPEG again, and make more edits to then save it as a JPEG again, because then you wind up with an absolutely fucked image. It gets bad. Every time you save a JPEG, you are compressing it again and again and again, losing data each time. And by the third or fourth save, depending on what your starting size was, it can start to look like garbage. Always work from lossless formats and only export to lossy from your lossless file. That said, I mentioned that we need to talk a little bit about a few other file types that don't fit neatly into these categories because they can sometimes be multiple things depending on how you export them. PDFs and PNGs both have some quirks that you need to understand in order to avoid problems with them. First, PDFs can be uncompressed, lossless, or lossy, depending on entirely your export settings. Same technically goes for TIFFs, so I'll lump that in here, but PDFs are going to be the important ones for the work that we're doing in this class. This is important because a lot of students just hit export PDF without checking the settings and wonder why their file either looks terrible or is absolutely massive, if they even bothered to look at their file size before I wait 30 minutes for it to download in Canvas, or sometimes as they are awestruck and wondering why it won't upload to Canvas in the first place. Anyways, PDFX for 2008 is the industry printing standard, and it gives you lossless or uncompressed quality. It kind of gives us both. High quality print, which is a setting available when you're exporting PDFs, is also a lossless format. And contrary to the name, it's actually not the industry print standard. PDFX4 2008 is instead the print standard, so use that. Smallest file size is another option in the PDF dropdown that essentially compresses everything. It is a lossy file type. You should avoid this for most things unless you're sending a PDF via email for the client to really just leave some feedback comments. Press quality uses some compression within the lossless file, more than it would with, say, like a high quality print export. So it's kind of like an in-between state. It's really weird. And again, not really the industry standard for use on press. You can essentially avoid this one altogether. I don't think I've ever had to use it properly other than maybe hitting it by mistake. Always check your export settings before saving a PDF. That's really important. And for this class specifically, please, we're going to do this I wouldn't normally recommend this, but for this class in particular, please submit just the smallest file size PDF so I can actually see your work somewhat quickly. There can be a lot of people in this class, so it's good enough for what we will need in class. But if you plan to send anything to print in your future, you can almost always default to exporting to PDFX4 2008. That's a good option to just keep in your workflow. This one is really confusing. I even get confused with it sometimes still. PNGs are technically lossless, but they're still flattened output files. You can't go back and edit layers in a PNG. You would need to return to your PSD file or your AI file to do that. PNGs are essentially larger than JPEGs, or at least they're generally larger than JPEGs, which means that they also take longer to load, and they also use more data when you embed them into things like websites and apps. So the only time you should really be using a PNG, especially for web and digital applications, is when your image needs a transparent background. You'll also hear those transparent backgrounds called alpha channels. So it's important that you know both of those terms. And when you do need transparency, be sure to use PNG 24, not PNG 8. PNG 8 is limited to 256 colors, and it has limited transparency options. I think it might not even allow for transparency if I remember correctly. So it's not suitable for most professional work. Stick with PNG 24 for transparency needs. For this section, here's just 5 quick pro tips just to kind of round this out. Start with uncompressed when possible. That means raw photos straight from your camera or uncompressed audio from your recording device. 2, always work in lossless formats like Photoshop files, Illustrator files, InDesign files. You can also work from TIFFs. Those are acceptable. You're not really going to be working straight from a PNG file, though you could. So I put that one in there, but be careful. That's a little bit of a red herring. Third, only export to lossy formats like JPEG or MP4 for your final deliverables. And then 4, never repeatedly edit and save lossy files. You will destroy the quality with each save. And then 5, it's important that you understand your export settings before you hit save, especially for PDFs, PNGs, and even some GIFs. These 5 rules, I promise you, they're going to help keep you out of trouble, and they're going to ensure that you're always working with appropriate quality levels for each stage of your process. All right. Next section. Let's talk a little bit about the different types of printing. I've alluded to this several times in the last 2 lectures. And that's because this is really where it started. This is really where graphic design, I should say, starts. I got my start in this industry in graphic design for print. And then I ultimately navigated my way into doing design for digital and web and became a UX UI designer. And now I do all of it, even photo video. So really, we can be somewhat fluid in this industry. And I think it's important that you know the origins, because you never know where you're going to end up. And the more skills that you have, I like to say that while a lot of you are going to be here for UX UI classes, some of you guys are here as GIT majors, some of you are primarily here as UX majors. Even though that might be your background, you never know what opportunities might come your way in the future. And if I can hire someone that has just UX skills versus someone who has UX skills and a little bit of printing skills, I'm going to go for the second all the time, because why would I pay more for less? There is genuine desire for specialties. So if that's your goal, specializing and becoming really, really exceptionally good in UX work can be helpful. But personally, I'm a generalist, not a specialist. I'm capable of doing a lot of things really well. Um, but that said, I maybe am not a perfect expert in Figma. I can get pretty damn far with it, but some of the more complex animations and micro interactions can sometimes trip me up, but I know where to find the answer. So that's kind of the big deal. Before we dive into all of these different printing methods, we need to establish some vocabulary here because I'm about to throw a bunch of terms at you. And if you don't know what these words mean, the rest of this is going to sound like absolute gibberish. So let's define these terms up front. Plates, a printing plate is a flat surface, usually metal, but sometimes it can be a polymer or even other materials. Polymers are the materials that like rubber stamps are made out of. And that plate or that substrate, the metal, the polymer, whatever material that plate is made out of, carries the image that you want to print. In plate-based printing, and these are specific methods like offset lithography. There's a few others, but the plate determines what gets inked and what doesn't. That'll make sense in a minute. Essentially, the image area attracts ink, and then the non-image areas repel it. And you need a separate plate for each color of printing on the press. There's different stations. So if you're doing 4-color CMYK printing, that's 4 plates, 4 different stations. One for cyan, one for magenta, one for yellow, one for black. Drums and cylinders. Yes, these terms are somewhat interchangeable. In printing, they both refer to cylindrical rotating components in a press. Sometimes you'll hear the term drum, sometimes you'll hear the term cylinder, but they mean the same thing. It's a rotating barrel that is part of the printing mechanism. In a process called gravure printing, the cylinder is actually engraved with the image, so it sort of takes the place of something like a plate. In offset, you can have multiple cylinders, and the plate cylinder, let me actually break them down. You can have the plate cylinder, so again, kind of taking the place of the plate. Then you can also have the blanket cylinder and the impression cylinder, and I think there's even a few others in there. Essentially, they all work together, rotating in sync to transfer the image onto the paper. Runs is another term, and you might hear this in 2 ways. You might hear the term short run versus long run. A run is essentially how many copies you're printing. A short run is typically anywhere from 1 to maybe 1,000 copies, maybe even up to 5,000 copies. A long run is thousands, even tens of thousands of copies, sometimes even millions. The reason this matters is because different printing methods are more or less economical at different quantities. And digital printing is great for short runs because there's minimal setup cost. Offset lithography becomes much more economical as your run gets longer because you've got a lot of really high upfront setup costs in order for that to get that press running. You have to pay to make plates, but then each additional copy of print after you've got all of those plates made are very, very cheap. So if you're printing 10,000 copies, offset setup costs get way cheaper per unit than digital. Another term that you'll hear is hits. A hit refers to one pass of one color. If you're printing CMYK, that's 4 hits. cyan hit, magenta hit, yellow hit, black hit. And if you add a spot color like a Pantone, maybe it's a gold color or something like that, then you've added a fifth hit to that process. More hits generally means more cost and more complexity because each hit requires additional setup, alignment, and drying time. Not to mention, it makes the process longer on the press, like physically longer. It requires more space. So, another term that you might hear is something called variable data. We're actually going to be working with this in class. This is the ability to change information from one printed piece to the next without stopping the press. Think of things like personalized direct mail. It would say, Dear John on one piece, and then maybe Dear Sarah on the next, each with different mailing addresses, different offers. And the nice thing about this is that digital printing really excels with variable data because there's no plates involved. You can swap out the information all you want. You're essentially printing a different file for every single piece. And traditional plate-based methods can't do this because the plate is fixed. A couple more for you. Planographic, or you'll hear this pronounced a couple of different ways. I usually say planographic, although that's technically wrong. It's actually planographic. This is just a fancy word that means the printing surface is flat. The image areas and non-image areas are on the same plane. There's no separation. There's no raised or recessed elements. This will make a little bit more sense when I get to some of the next ones, like relief and Intaligo. Offset lithography is a type of printing that is planographic. The plate is flat, and it's actually really interesting because it relies on the chemical principle that oil and water don't mix in order to keep the image areas and non-image areas separate from each other. It's really complex, and it is fundamentally chemistry. So kind of interesting stuff there. Relief is printing. It's sort of the opposite of planographic or planographic. The image areas are raised, just like a stamp, like a rubber stamp. They stick up from the surface. Think of a rubber stamp is really the best example here. The parts of that print that are going to be inked are sitting higher than parts that don't print. The letterpress and flexography options for printing, I'll get into all of these different options in a moment, are both relief printing methods. You ink the raised surface just like you would a stamp, press it onto paper, and the raised areas transfer ink while the recessed areas don't touch paper at all. And then Intaligo or Intellego, there's a couple of different ways that you'll hear people pronounce it. I do believe the correct pronunciation is Intelligo. I do believe it's Italian. And Italians, just like lasagna, don't really pronounce their G's. So I believe it's Intellegio. This is the opposite of relief. The image area here is actually recessed below the surface. And oftentimes it's very, very, very like microscopically small holes. Gravure is a printing method that uses intaglio. Just tiny, tiny cells that are engraved into oftentimes like a brass cylinder and it uses enormous amounts of pressure, which is why the cylinder is usually made out of brass. And what happens here is that the cells, the individual holes within that cylinder, fill with ink, and then what's called a doctor blade wipes excess ink off of the drum, and then paper is pressed against the cylinder with enormous pressure so that the ink gets pulled out of those cells and then is transferred onto the paper or whatever substrate, really. From there, you have blankets, and in offset printing specifically, the blanket is uh, it is often a rubber coated cylinder, and it sits between the plate and the paper. And the reason it exists is that the plate will, particularly in drum sets, it will transfer the inked image onto the blanket, and then the blanket then transfers the image to the paper. Very interesting stuff there. It's really complex, so I kind of had to visualize that one. This is called offset because the image itself is offset. It doesn't go directly from plate to paper. Um, the blanket is typically made out of a softer, sort of squishy material, so it can just print on things like slightly textured papers a little bit more effectively. And it also protects the plate with the image from wear and tear, so it doesn't break down as fast. And then you'll also hear terms like roll fed versus sheet fed. These terms describe how paper enters the press. We're probably most familiar with sheet fed, which means that individual sheets of paper are fed into the press one at a time, just like your printer at home. This is common for offset press making or press printing. You would use this for printing things like brochures or business cards typically. And then you might also hear the term roll fed. Sometimes this is also called web printing. And this means that the paper is rolled on a giant spool or a roll of paper that runs through the press continuously, and that whole roll goes through the press and gets cut at the end after everything is printed. It all gets cut to size, sometimes on the press, sometimes off the press. Just depends on the setup. Roll fed is surprisingly fast and way more economical for really long print runs, which is why a lot of newspapers and magazines are typically printed this way. But sheet fed gives you more paper options and is much better for shorter runs. Oftentimes labels for packages, those are often roll fed or web printed, whereas again, like brochures and things like that, that'll be sheet fed. Substrate. This one's an important one. I'm going to use this a lot. I probably have already used it several times, but this is just a fancy word for whatever you're printing on. It doesn't have to be paper. It could be plastic, it could be fabric, metal, wood, whatever. We use substrate instead of paper because not all printing is on paper. When someone asks what substrate are you using, they're asking what material is it being printed on. I've mentioned this one already, Dr. Blade. This is a specific component, particularly in gravure and flexography printing. It's just a very thin blade, almost like a squeegee, though it's usually metal, that scrapes excess ink off the printing cylinder before it contacts the paper. That way you don't get smushy ink everywhere. And the Dr. Blade just ensures ink only stays in the engraved cells or the image areas and not everywhere else on the cylinder. And it's called the Dr. Blade because doctors or cleans, let me rephrase that. It sort of doctors or cleans the surface of the substrate. Think of it kind of like a shower head, but for ink, and there's no water involved. The print head contains dozens or hundreds of, even thousands of tiny, tiny, tiny nozzles. And each nozzle can fire individual, wait a minute, sorry, I missed a step. I skipped ahead in my notes here. Moving on to print head. Sorry, guys. It's late. It's currently 11 o'clock at night as I'm recording this. Bear with me. Print heads. A print head is a specific tool to digital printmaking, mainly inkjet. Um, it's really just the component that actually deposits the ink onto the substrate. This one you can think of as a shower head. I apologize, but for ink. The print head contains dozens or hundreds or even thousands of tiny little nozzles, and each nozzle can fire individual droplets, or really it's more of like a spray of ink with very, very high degrees of precision. And the print head moves back and forth across the paper, usually on something called a carriage. And print heads are just incredibly complex pieces of engineering. They are firing tiny, 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 tiny microscopic droplets measured in something called picoliters, which is 1/1,000,000th of a liter. Absolutely tiny. In large format inkjet printers, which can be 65, I think even 80 inches wide, you might have multiple print heads working simultaneously. And importantly, if a print head gets clogged or if it fails, that's usually a very expensive repair because they are highly precise instruments. Jumping into the various types of printing, let's start with digital printing. This is probably what you're most familiar with because it's what most of us have access to. Digital printing is considered to be a direct-to-substrate printing method with no plates. You send a file to the printer, it prints, plain and simple. That's how it works. There are two main types. You have toner-based and inkjet. Toner-based printing, like a laser printer, works by using an electrostatic charge bound. It's sort of a bond between paper and powdered toner. And then the printer ultimately uses heat to fuse the toner to the paper permanently. Inkjet works by spraying tiny microscopic droplets of liquid ink directly onto the surface. And if you look at the image here, you can see an inkjet print head in action. There are individual droplets being sprayed onto the paper as it moves through the printer. Now, for each of these different print types, I've listed some reasons why you might choose it and some common applications that you would see these in. I've also mentioned when you probably won't want to use this. I encourage you to read those. I'm not going to read through them for each category just because you're fully capable of reading. Offset lithography often is just called offset or litho. You'll hear both of those terms. I typically use the term litho. This is a plate-based planographic printing method. Remember that term, planographic? That's where the printing surface is just flat. Offset printers work off the principle that oil and water don't mix. Essentially, a metal plate is created where the image areas attract oil-based ink and the non-image areas attract water. And the plate gets inked, and that ink image transfers onto a rubber blanket cylinder, and then which is then transferred to the blanket and then to the paper. That's why it is called offset printing, is that the image is offset from the plate to the blanket before it hits the paper. And if you look at the diagram here, you can kind of see the whole system. You've got the printing plate wrapped around the plate cylinder, and then ink rollers applying ink to the plate and a dampening unit sort of applying the water that's involved in the system. And then you've got the blanket cylinder that receives the image from the plate, and then finally the impression cylinder that presses the paper against the blanket. It's really quite a beautiful and elegant system. And then at the bottom, you can see how this works for full 4-color printing. You need separate printing units for each color you're printing. And those inkwells don't need to necessarily be filled with cyan, magenta, and yellow. They could be a Pantone or really any color you want. Oftentimes you will still run a CMYK, but then maybe add additional colors on top of it. But they could be Pantones if you wanted them to be. They could even be coatings or varnishes. The nice thing about this is that the paper runs through multiple units or stations sequentially, and each color gets layered on top of the others to create the final full color image. And typically you'll start with black first. That's why it's the key color. It's the registration color. That black keeps all the other colors in registration. Then you would go with blue, then magenta, then yellow. You kind of work from darkest to lightest typically. Flexography, similar to litho, flexo is usually just called flexo. It's a relief printing process with flexible plates, usually made from polymer. And relief printing means that the image areas are raised above the non-image area, just like a rubber stamp works. If you go and look at a rubber stamp, I usually have one sitting around here somewhere. If you go and you look at a rubber stamp, you're going to see raised areas on that. That's exactly how this works. But usually it's a thin piece of polymer that is lasered or etched out and then sized to the printing drum, essentially. The way that this works is that you essentially have a raised printing plate made of that flexible photopolymer, just like a rubber stamp is made out of. And these plates are then mounted to these cylinders that you see here. Again, those cylinders, those big round things, those can also be called drums. And as the cylinder rotates, it picks up, in this situation, really fast drying inks. And those inks then transfer directly from the cylinder with the rubber stamp polymer on it to the substrate. So directly from the cylinder onto the paper. So this is not an offset process. Flexo is almost always roll fed as opposed to sheet fed, meaning that the paper or film or whatever material your substrate is comes off a giant roll or a spool of paper and runs continuously through the press. And if you look at this image, you can see an actual flexo press in action. This actually has one of my projects on it. Those are the multiple printing cylinders, each one carrying a different color plate. And you'll notice how everything is set up in line. The substrate just keeps moving through, getting hit with color after color in rapid succession. Here you can see the numbers off to the left. Those are the number of stations available. Each station can only hold one color at a time. Now, I know from working with this printer directly that this is actually an 8-station press. So I could honestly put up to 8 separate colors on this press as long as I didn't have any things like coatings and varnishes in my file. However, this specific job that is going through the press in this photo here is only a 2-color job plus a matte varnish, meaning that we only needed to use 3 wells in order to make that happen. So interesting. We had 2 colors. We had a green and a red, and then the matte varnish. At the very bottom right is you see this sort of inkwell station, but it's got this kind of milky white liquid in it. That's the matte varnish that is feeding one of the drums. So cool stuff happening here. Let's see. Yep, I think I covered everything there. Gravure, sometimes you might also hear this called as rotogravure. It's an intallago, nope, said that wrong again. Nope. See, you can only get so many out of me before I start saying things wrong, especially when they're weird words like that. Um, Especially for this kind of printing, it's really just reserved for ultra, ultra, ultra high volume work. IntelliJ means, see, there we go, I got it. It means that the image areas are recessed below the surface. It's the opposite of Flexo's relief style printing. So here, this is an example of where you have these really tiny holes, microscopically small. You'd need a magnifying glass in order to see them. The cylinder rotates through an ink bath as opposed to a well, though it's similarly shaped. And that bath fills all of those holes with the ink. Then the doctor blade scrapes across the cylinder, wiping away the excess ink from the surface. So ink only remains in the engraved cells. Then paper is pressed against the cylinder with enormous pressure, and the ink gets pulled out of those cylinders onto paper. And if you look at this diagram here, you can see the engraved cylinder sitting in the ink fountain, the doctor blade scraping off the excess, and the paper being passed against it by the impression roller up at the top. Again, another extremely elegant system, but really reserved for high volume work. So unless you're printing a million copies, or you've just got money to burn, gravure just doesn't make a whole lot of financial sense. And this is not a fast process. Those drums are tens of thousands of dollars each, and you need one for each color. So good luck. Screen printing, also called silk screen. Most of you guys are probably somewhat familiar with this. I'm not going to spend too long on this one, but you essentially just have non-image areas blocked out by a screen, and the image area is sort of, you've got a fine mesh screen stretched over a tight frame. You block out the non-image areas, usually through light exposure, almost like developing film. And anywhere where there isn't an image, ink won't be let through. And anywhere where there is an image, ink will be able to go through. Then you put the screen on top of your substrate, usually something like a t-shirt or a poster. Really, you could silk screen anything. And then you pour ink onto the screen and then use a squeegee to push the ink through those open areas in the substrate, or open areas in the screen onto the substrate. So pretty simple process here. And then we have letterpress, which is another relief style printing method with tactile impression, much like Flexo. However, unlike Flexo, this is one of the oldest printing methods available. It's extremely similar to how the Koreans made the Triptychana Koreana in the 12th century, and how Gutenberg printed the first production Bible. It's how newspapers were printed for centuries. And now it's having a pretty big resurgence, particularly for like wedding and boutique stationery. It's kind of cool. And then risography, or sometimes just called Rizos, is it's kind of its own weird, wonderful thing. It's technically a stencil duplicator that uses individual color drums and soy-based inks. So a little bit of a different process here, but you get this sort of overlaid color look, especially with overprint when you set that in Illustrator. I'll get to that in a bit. And then you have the dye sublimation process. This one's really quite special. Actually, this print that's on my wall back here, I'll stop sharing for a second. That photo print, that's printed on metal. And just to prove it, there you go. It's printed onto aluminum. This is dye sublimated. So essentially in that process, it works a little bit different. You are printing onto a thermal ribbon first, and then your image is using special inks. printed onto that die sheet, and that die sheet has your image printed onto it, specifically formulated with sublimation dyes. And then you place that sheet against your substrate. Maybe it's metal, maybe it's a clothing or a shirt. And if it's a shirt, it specifically has to be polyester fabric or some sort of, it has to transfer to some sort of polymer. And then you apply heat and pressure, and the heat causes the solid ink to turn into a gas. And that sublimation, when something goes directly from a solid to a gas without becoming liquid, that's called sublimation. That gas penetrates into the polymer fibers or polymer coating and then solidifies again, permanently becoming a part of that material. So very sciencey approach. If you look at this diagram, you can kind of see the thermal ribbon. This is actually kind of a bad diagram, but you can see the thermal ribbon with the dyes, and then the heating elements applying heat, and then the coated paper receiving the transferred image. And the whole process happens in one pass. It's fascinating. Pad printing, another slightly fringe one. These are getting popular on TikTok. There's a lot of videos of people like dressing the pad printing. So watch one of those if you want to see these in action. But essentially you just have an etched plate similar to gravure that holds your image, and then the image areas are recessed below the surface, and then that plate gets inked. A doctor blade wipes the screen off the excess, and that leaves only the recessed image areas left. Then a silicone pad, which is what you're seeing here, dips into the ink, moves over, presses onto the product, back and forth. Really good for transferring ink onto three-dimensional shapes and other irregular surfaces. Last one here, this is lenticular printing. This one's super fringe, but when I figured out what this thing was called, I was like, oh my God, I've always wondered what that was called. This is like those 3D animated gift cards that you can buy that have like the itchy sound on them. I call it static. As a kid, we would always like scratch our fingernails on these things. But they are motion. You can almost imagine this image moving, and Mickey would sort of change. It just helps create the illusion of depth or motion. But you need multiple images for this, either different frames for animation or different perspectives for 3D depth, or completely different images for sort of what's called a flip effect. And then those images get interlaced, sliced into strips, and then woven together and printed on the back of what is called a lenticular lens sheet. And the lens refracts different strips of the image depending on your viewing angle. So as you move or tilt the print, you see something slightly different. All right. Last section, technically, but this one's a doozy. So bear with me. I know it's been a bit of a long lecture. I do apologize. But this one's super, super important. Color is interesting. Some of this can get a little bit geeky, so just bear with me on this one, but I promise this is way more interesting and technical than you might expect. Color is one of the most complex topics in design. Color is physics, color is psychology, color is chemistry. It's a lot of math, namely trigonometry, and still a lot of it is just our imaginations. It's the wildest thing. So what is color? It's actually an event that requires three things: a light source, an object, and an observer. Without all three, color actually doesn't exist. In a completely dark room, objects don't have color because there is no light. Color is fundamentally about perception. Light is projected from a source. This is called luminous energy or flux. And then light that hits an object then create luminance because that object is now illuminated. Then certain wavelengths are absorbed by that object, and any wavelengths of light that are not absorbed then reflect back, enter your eyes, creating illuminance, luminance, and your brain then sort of interprets those signals as color. All of this is an interaction between physics and our human perception. So, to put it simply, you are imagining color. World shattering stuff here. But don't worry, it gets worse. To break that down a little bit more simply, here's the process. First, light is projected. That's luminous energy or flux. Second, light illuminates an object. That's called luminance. And then third, that object absorbs certain wavelengths and reflects others. After that, those reflected wavelengths enter our eyes, creating luminance. Fifth, the cone cells in our retinas direct those reflected wavelengths. And lastly, our brain interprets those wavelength signals as color. Here's the mind-bending part. A red apple isn't actually red. I know, right? The apple doesn't have redness. It's just reflecting certain wavelengths that our brain interprets as red. It's actually what is actually happening is it is absorbing blue and green light, and it is reflecting only red light. If you were to change the color of the light source, you would then theoretically change the color you perceive that apple to be. Again, wild stuff. Let's go down a little very quick physics detour. And I know we're at like 2 hours plus here. But I have a question for you. Is light a wave or a particle? Sir Isaac Newton said that it was a particle. Huygens said it was a wave. But it turns out that both were right. It actually took quantum physicists Max Planck and Albert Einstein to figure out that light has properties of both. And they called it a wavicle, or now we call them photons. And this wave-particle duality is fundamental to understanding light and color. In design, we mostly care about the wave properties of color, wavelengths and frequencies. But just for the heck of it, let's take this detour just a little bit further. A photon is simply a pulsating packet of energy that has it traveling at the speed of light. It is a pulsating packet of energy traveling at the speed of light. And all photons move at the same speed, but they have different levels of energy that then produce different wavelengths. Higher energy photons produce shorter wavelengths, which result in colors that we would then translate as being cool colors, like blue or violet. Lower energy photons produce longer wavelengths, resulting in colors that we would perceive as being warm colors like red and orange. And this relationship between energy, wavelength, and frequency is the foundation for understanding color. Being completely honest with you, this isn't something I have to think about every day or even every time I'm picking a color palette, but it can help to understand this as we get a little bit further into understanding color science and what color really is. Just to give you a little bit of a visual here, these are some of those higher energy photons that pulse at shorter wavelengths and higher frequencies, whereas lower energy photons pulse at lower wavelengths and lower frequencies. And this image shows the electromagnetic spectrum, and the tiny itty bitty portion that is visible to our stupid human eyes. As you can see, the human eye can only see a very small section of the spectrum that ranges from about 700 nanometers to about 380 nanometers. And for reference, a nanometer is 1 billionth of a meter, which is pretty darn small. The color sensations produced by the different wavelengths dictate the colors that you ultimately see. Longer and lower frequencies appear to be red. Shorter wavelengths with higher frequencies appear to be blue. While most of us as designers are primarily worried about the visible spectrum of light, it is helpful to understand the impact of near visible light as well, especially if you plan to do any work in photography or print. Digital cameras are actually very sensitive to infrared or IR light and require what are called IR cutoff filters to help eliminate false color sensitivity. And then ultraviolet light can have an impact on prints because optical brightening agents, or OBAs, can change UV light to visible light and change the appearance of how a print ultimately looks. And it produces this almost a subtle effect that is similar to if you held a black light up to a white t-shirt, you'd get this slight purplish glow. OBAs can also have a negative impact on the longevity of a print, which is an entirely more technical issue, but would then introduce fading into your print, essentially. So now that we understand a little bit about how we perceive color, I want to introduce you to a pretty critical concept that I do think about and use every day of my life. And you're going to as well. You need to know the difference between additive and subtractive colors because they are fundamentally different systems, and you will need to use them both in this class and out in the industry. Additive color is essentially how screens work. Your monitors, phones, TVs, projectors, anything that emits light, even something like a flashlight, will use additive color. And with additive color, you start with darkness, black, and you add light in order to create color. And when you add red light plus green light plus blue light together, you get white light. I know that's a little strange, but we'll get to that. The more light you add, the brighter and lighter your color becomes. Hopefully that makes sense. Subtractive color, on the other hand, is how printing works. And anything involving ink, paint, dye, on any sort of pigment on a physical substrate like paper, with subtractive color, you start with white, and usually the white of a paper is kind of a good baseline. And then you add pigment that subtracts or absorbs certain wavelengths of light. Okay, so we're measuring light and color towards white. When you mix cyan, magenta, and yellow together, theoretically, you should get black. However, in reality, you kind of get this ugly, muddy brown. We'll talk about why that happens in just a second. But the key thing is the more pigment you add, the darker your color becomes. This is fundamental. This is the fundamental difference between these two systems. It's exactly why your designs might look a little bit different on screen versus when you go to print them. You are literally using two different color systems to produce color. One adds light, one subtracts it. Going a little bit deeper with that, RGB is, again, the additive color space, and it is used for anything that emits light. Basically, any digital display uses 3 separate channels to form a pixel. You're actually looking at a pixel array here, and they are composed of red, green, and blue lights. Each channel can have a value from 0 to 255, which gives you 256 total possible values per channel. If you do the math, 256 to the power of 3, one for each color, equals about 16.7 million possible colors. Those 16.7 million colors are the theoretical color gamut. In other words, the complete range or scope of the RGB color space, which sounds a lot. It sounds like a lot. It really does. But it's still not all the colors that human eyes are capable of perceiving. We'll come back to that in a bit. But when all these channels are zeroed out, you get black because there's no light being emitted whatsoever. All the pixels on your display are essentially turned off. However, when all the channels are maxed out to 255, so 255 red, 255 green, and 255 blue, you get white, which is full intensity. Full intensity, bright light blasting at your eyeballs. All the pixels in your display are at full intensity, blasting straight at your corneas. That's how that works. This is why many devices offer dark mode, because obviously it hurts our eyes less. I don't care what anyone says. You can like or not like dark mode. It will hurt your eyes less, I promise. But it also has the added benefit of prolonging your device's battery between charges. So go figure. The beauty of RGB is that it actually maps pretty well to how our eyes work. Remember those cone cells that we talked about? We have 3 types of cones within our eyes that are sensitive to roughly red, green, and blue wavelengths of color. So RGB is kind of mimicking our biology in a way, which makes it a bit more intuitive for those of us who will ultimately go on to do digital design work. This is also why RGB is the default color space for anything screen-based. So just keep that in mind. It's going to come in handy later. Now, let's talk about CMYK. This is the subtractive color space, primarily used for print. CMYK stands for cyan, magenta, yellow, and key. You might be wondering, why key? Why not just B for black? In traditional printmaking, the black printing plate is the key plate that all other colors are aligned to. So it's called key black, or just K for short, as a little bit of a relic. Each channel in CMYK ranges from 0% to 100%. And that percentage represents how much ink coverage you're applying to the paper. Here's where things get a little bit interesting. And by interesting, I mostly mean frustrating. Theoretically, if you were to mix cyan, magenta, and yellow inks together, you should end up with black, because you are subtracting the wavelengths of light. But in reality, printer inks just aren't really all that perfect, so they don't absorb and reflect wavelengths in exactly the way pure pigments, which truly don't exist, would. So when you mix cyan, magenta, and yellow, you actually end up with this ugly, muddy brown color. Plus, using 3 different inks to create black would use way more ink than would be necessary, which ultimately costs money, especially over the course of hundreds or even thousands of prints. So it would also just take forever to dry because there's so much ink on the page, which would then slow down production, and it could also oversaturate the paper, or even cause the paper to warp. In really thin papers, it might even bleed through to the backside of the page. None of those are good things. That's why we added a separate key black as the 4th color. That's your K. Additionally, adding the key black and combining it with very light touches of cyan, magenta, and yellow creates a much nicer looking, richer, truer black that still saves ink. And it has the added benefit of solving all of those previously mentioned problems. And we call this four-color process printing, or just CMYK. And speaking of rich black, not all blacks in, or at least not all black inks, are created equal within printing. There are actually two main types. You have key black and rich black. Key black is just the black ink all by itself. The formula for that is cyan 0%, magenta 0%, yellow 0%, and black, or key black 0 to 100%. That is a flat single black ink. Here, that's the one that's on the left here. And that ink is just straight out of the cartridge labeled K on your inkjet printer at home. Same exact thing. You only want to use key black for body text and fine details because it helps keep those smaller fine lines and details a little bit sharper. If you used multiple inks for small text, you'd sort of risk creating registration issues. And misregistration is when the different color plates don't line up perfectly on press. And if your text is made of 4 different inks that are even slightly misaligned, your text is going to start looking a little bit fuzzy or have these weird rainbow edges. Not good. So for small, typically less than 6-point text in something like a book, try to stick to key black. If your text is larger than 6 to 8 points, you can kind of go nuts. On the other hand, you have rich black, which adds a little bit of cyan, magenta, and yellow underneath that key black to create a much deeper, much more saturated black. And a common formula, which there are many for a rich black, is cyan set to 60%, magenta at 40%, yellow at 40%, and then the key black at 100%. Rich black has a lot more sort of punch or depth to it, and it looks darker, typically more luxurious, a little bit more intense. Really, this should kind of be your default black for most of the time for large areas like backgrounds, header text, or really anywhere you want really deep saturated black that has just a bit of weight to it. Just be mindful of the substrate that you're ultimately printing to, because if the substrate is too thin, you can still get warping and bleeding out of this. The difference is actually pretty subtle when you're looking at it on screen, but in print, it's actually super significant. Rich black looks deeper, more saturated, while a simple key black can look just a little bit flat or even grayish, especially over large areas. So knowing when to use which one is part of just being a good designer. And this is actually a good opportunity for me to tell you about a setting that you all should probably go and change in all of your Adobe apps that you've downloaded. Within each application, go to Settings and then to Appearance of Black. Set your on-screen dropdown to display all blacks accurately, and then set your printing or exporting to option to output all blacks accurately. This will just help you to be able to see the difference between rich and key blacks a little bit more easily. Oops. There we go. All right. Lab color is interesting. Lab is probably the color space you'll hear about the least in your day-to-day design work, but conceptually, it's actually a super critical color space, but maybe one of the most challenging ones to understand. Stay with me on this one. Lab is a device-independent color space that represents all colors perceivable to the human eye. Not just the colors your monitor can show, not just the colors a printer can print, all the colors a human eye can see, period. So here's how that works. L stands for lightness, and it ranges from 0 to 100. You can think of it as a vertical axis going from black at the bottom to white at the top. And then you have two additional color axes. The A axis goes from green on one end to red on the other. And then the B axis goes from blue on one end to yellow at the other. These aren't tied to any specific device. They are based purely on humans' perception of color. So you might be wondering, why does lab matter if we really don't use it to directly specify our colors? It matters because it's the reference space for all other color systems. It is a universal translator, sort of the Rosetta Stone, if you will, for color. And when you convert a color from RGB to CMYK or vice versa, which you're going to do constantly, the software doesn't simply go straight from RGB to CMYK. It actually goes from RGB to lab, then lab to CMYK, or the other way around if that's the way you're going. Lab is sitting in the middle, acting as this intermediary that makes sure the color translation is as accurate as possible. Lab also has the largest gamut of any standard color space. It contains all the colors in RGB, all the colors in CMYK, and then a whole bunch more that exist in neither system that no system can reproduce per se. So while you might not be creating files in lab color space, just know that it's working behind the scenes every single time you convert between different color modes. There's actually a cool trick when you're working in black and white photography. If you're in Photoshop, you can convert to lab color mode. Well, actually, first you convert your image to grayscale, then convert it to lab color. Go into the channels and remove the A channel from, actually, I think you either remove just the A channel or both the A and the B channel in order to get essentially just pure lightness, and you get a much richer black and white image. It's kind of cool. Lab values are essentially just based on the color theory that they're really just unsung heroes of color management. So it's once you really understand how lab colors work, they're super valuable. Now, talking about hexadecimal color codes, or hex codes for short. If you've done any web design or coding at all, you've probably seen these. Hex codes are just RGB values expressed in a different notation that computers and code languages prefer. Instead of writing RGB 25500 to indicate red, web designers and developers can just write FF0000. It's the exact same color. It's pure red, just written in hexadecimal format instead of numerical format. The format is always 6 characters, hence the hexa in hexadecimal. For all of you Greek word fans out there, and the format is always the first 2 characters after the hash represent the red channel, the next 2 represent green, and then the last 2 represent blue. The values for each hex range from 0 to FF, or actually it should be 00 to FF. In hexadecimal, FF is the highest value. It equals 255 in decimal. So FF0000 is red 255, green 0, blue 0. You'll see hex codes everywhere in web design, particularly within CSS, HTML. You'll use it in Figma, and essentially every design software you will ever touch in your life has the ability to use hex codes, even when they shouldn't. They are beautifully compact, easy to copy and paste, super intuitive way to communicate RGB colors, and web browsers know exactly what to do with them. You'll use these constantly within design work, so just get comfortable with them. It's just a different way to specify color for the RGB color space. And that's kind of an important note. It's so important that I actually put it in Spanish. So make sure you're paying attention here. Adviso muy importante. Do not use hex codes to specify CMYK colors. Let me say that once again for the people who weren't paying attention. Do not use hex codes for print work, period. I see this mistake constantly. It drives print production teams absolutely insane. Hex codes are fundamentally, inherently, inextricably tied to RGB color. They are RGB color values, just written in hexadecimal notation. If you send a printer a hex code and tell them to match it in CMYK, you're essentially asking them to translate RGB color into CMYK, and that translation is not straightforward. It's not even one-to-one. Different RGB colors convert different CMYK equivalents. And here's the kicker. Some RGB colors can't even be reproduced in CMYK at all. Since RGB is a much larger color space than CMYK, it has a larger color gamut. I'll get to that in a bit. You are essentially specifying a color that is out of gamut. You could be specifying a color that is out of gamut. We'll talk about that in a second. It's important that when you're working in print to look for this little out of gamut warning. I've put it in the image here. It's a little triangle symbol with an exclamation point in it inside your color picker. It's in most Adobe applications, and it's telling you that the color you've picked is outside the printable gamut for CMYK. You will not be able to even remotely replicate that color. If your intent is to use that color in both digital and print applications, you should pick a different color or spec a Pantone, for God's sake. We'll talk about those in a minute. By using a hex code for a print job, you're basically saying, hey, here's the color that might not even be printable, and I'm not going to tell you what the actual CMYK value should be, so just figure it out. That's not professional. That's not how you want to work, and it makes you look stupid because then the printer knows you have zero idea of what you're doing. When you're designing for print, you specify colors and CMYK values. You can also use things called Pantone colors or CXF files. Never, 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 never hex codes for print. Your colors will be wrong, your printer will be annoyed, and you will look like a damn fool who doesn't know what they're doing. Don't do it. All right, moving on. I've already mentioned these a few times. Color gamut, Pantone, CXF colors, what are those? Let's start with color gamut. The gamut is simply the range of colors that a device or a color space is capable of reproducing. Not all color spaces can reproduce the same colors, and this is one of the biggest sources of frustration and confusion in design. Lab, like we talked about, contains all perceivable human colors. They actually fall outside of traditional color gamuts. They're sort of off the charts. It has the largest gamut. RGB screens have pretty wide color gamuts. There's actually a couple of different options. There's actually one beyond Adobe RGB, which is the biggest triangle that you're seeing here, called ProPhoto RGB. That's primarily used by photographers. Again, mostly for raw uncompressed files, but RGB, essentially used for screens, have pretty wide gamuts that are not nearly as wide as lab colors. There are colors humans can perceive that RGB color space is not capable of replicating. In other words, those unreproducible colors are out of gamut. And then CMYK, or print, has the smallest gamut of the three. And this is actually quite frustrating for those of us who have worked in the print space because it's actually extremely limiting. In practical terms, this means some colors you see on your screen really can't be printed, period. They're outside the CMYK gamut. a bright, vibrant neon green that looks absolutely amazing on your monitor. CMYK inks physically cannot reproduce that green color. A bright, super saturated blue, it might print, but it's probably going to look a little too cyan and maybe a little bit dull. This gamut limitation is exactly why designs that look bright and punchy on your screen can tend to look a little bit muddy or disappointing when they come back from the printer. The color you designed literally does not exist within the printable spectrum in those situations. And the printer isn't necessarily doing a bad job. They're just limited by the physics of ink on paper. As I mentioned previously, there are some notable exceptions to this. If you happen to be printing in advanced inkjet printers, you might have more ink heads that you can work with that can get relatively closer to the CMY, or I'm sorry, to the RGB color space than CMYK. So it's important that you know what type of printer that you're going to be working with for any print projects. That's why we went over all of that before you start working on your design. It actually determines a lot about how you will ultimately build your files. But beyond that, understanding color gamuts helps you make smarter design decisions as a designer from the very beginning. If you know you're designing for print, you probably need to be thinking in CMYK from the start, not designing in RGB. And then converting it later, because when you convert, colors that are outside the CMYK gamut will shift, and you might not like what they shift to. So it's best to just start in the color space that you're going to be outputting to. So why does all of this actually matter? Why do we care so much about colors or color spaces and color gamuts and all this technical stuff? Mainly because brand consistency is everything. Companies spend millions, sometimes billions of dollars ensuring that their brand colors look identical across every single touch point on every continent in the world. And there's a really good reason for that. The Institute of Color Research found that people make subconscious judgments about products within 90 seconds of seeing them. And up to 90% of that assessment is based solely on color alone. 90%. Color is the first thing consumers notice. It's one of the most powerful elements of brand recognition, and we can and should leverage those as designers. Think about it. If you see a can of Coca-Cola and the red is even just slightly off, a touch too orange or a touch too pink or ever so slightly too dark, your brain immediately goes, something's wrong here. This is a knockoff. Has this expired? Did they change the formula? Inconsistent color erodes consumers' trust, period. If Tiffany blue is even slightly off, it damages the entire perception of luxury and exclusivity that that brand has spent over a century building. If UPS brown varies from truck to truck or box to box, consumers might not recognize the brand, which then defeats the entire purpose of consistent branding and developing brand and design systems in the first place. This is why we spend so much time talking about color spaces and color management and gamuts and all of these technical details. This is not just academic jargon that I'm throwing at you. While I am a nerd who loves color theory, I have way more fun topics that I would much rather teach you. This stuff has real business consequences, and getting color right, understanding how to manage it across different media, knowing the limitations of different color systems, that's all part of being a professional designer. And I beg you all to take it seriously. And honestly, clients, stakeholders, and hiring managers, they may not have the words to communicate it, but they notice this. When you can talk intelligently about why their logo looks different on their website versus their business cards and what you're trying to do to manage that, that is the difference between looking like an amateur and getting passed up versus looking like someone who actually knows what they're doing and ultimately gets the job. All right. Before we dive into some specific color systems, I want to introduce you to a term that you might hear in the industry called color metrology. Metrology in general is just the science of measurement, and color metrology is specifically the science of measuring and quantifying color to ensure accurate reproduction across different materials, lighting conditions, and production methods. This is where we stop talking about color as subjective color. Something like, looks pretty close, or um, a warm pinkish red, right? Um, we're going to move away from that. We're going to start talking about objective color. Um, that measurements at, let me think about this. We can, I'll get to delta E's in a minute, but we'll circle back to that. But color metrology essentially gives us tools and standards to measure color scientifically. And then we can communicate those measurements precisely and verify that what we specified is actually what we got. And that's really important in this industry. All right. Pantones are one way to do that. And you've probably heard of the Pantone Color of the Year. I've mentioned Pantones a few times in this lecture, and they've become a little bit synonymous with color in the design world. So it's important for you to know. Pantone is a standardized color matching system that uses pre-mixed inks. Each color in the Pantone library has a unique number, like PMS 186C. That number refers to a specific ink formula that printers can mix to match it exactly. The way it works is relatively straightforward. Pantone essentially publishes physical swatch books that show you exactly what each color will look like when it's printed. You can hold it in your hands, you can see it under different lighting, compare it to other colors, and now these swatch books are super expensive and they do expire, which is annoying. This is because inks fade over time, usually after about a year or two. So if you're using a swatch book that's 5 years old, these colors are just not going to be accurate anymore. You need to replicate them, or I'm sorry, replace them somewhat periodically. And when you're speccing Pantone colors, you want to make sure you're doing it under primarily what's called D50 or 5,000 Kelvin degree lighting for printed materials primarily, and then D65 or 6,500 Kelvin lighting for textiles and hard goods in a calibrated booth. It's actually very precise. This is because if you remember from the beginning of this section, color is just a phenomenon that we make up in our heads. And based on how the light hits an object, if the color temperature of the light changes, so too does the color of your swatch. So we want to ensure that we're always looking at swatches under super calibrated lighting. But here's the real genius of the Pantone system. It completely removes subjectivity from color communication. Instead of having to say, I want a red that's kind of cherryish, but not too orange, with a little bit of depth, but not too dark, you could just say, I want Pantone 186C, and every single printer and designer in the world would know exactly what color you want. There's no ambiguity, there's no interpretation. It's Pantone 186C, period. This guarantees consistency across print jobs. You could print something in Phoenix, then print the same thing in Shenzhen, and as long as you're both specifying the same Pantone 186C, the colors should be identical. That's incredibly powerful for brand consistency, especially for companies operating globally. However, things did get a little bit messy in 2022 when Pantone and Adobe had a little bit of what I like to call a breakup. They ended their licensing agreement, and Adobe removed all Pantone colors from their apps. Photoshop, Illustrator, InDesign, all of it. If you want access to Pantone colors in Adobe apps now, you have to pay for a separate subscription to something called Pantone Connect, which is an absolutely perfidious piece of software designed as a plugin. And to design a piece of software whose only task was to allow users to select very specific colors this poorly was an execrable humanitarian gesture. It was, oh, and the stupid thing's not cheap either. It's $180 per year or $21 per month on top of your already expensive Adobe Creative Cloud subscription. The design community absolutely lost their minds over this. Designers were furious. There were articles, Reddit threads, Twitter rants, the whole shebang. Mainly because suddenly this system that had been the industry standard for decades was locked behind yet another paywall. A lot of designers responded by just abandoning Pantone altogether, and honestly using CMYK values instead, or alternative spot color systems, or just working around it however they could. It's honestly still a little bit of a mess. And the industry is still trying to figure out how to deal with it too. The whole situation is a little bit frustrating because Pantone used to be this universal language that everyone spoke. Now there's this barrier to entry that didn't exist before, but it is what it is, and we all have to adapt. That being said, despite all the drama with Adobe, Pantone is still the legal standard for trademarking colors. If you want to trademark a color, actually legally own it within a specific product category, you have to specify it using Pantone. Barbie Pink is Pantone 219C. Mattel owns that color for toys. Tiffany Blue, sort of that iconic robin's egg blue, is Pantone 1837C. And fun fact, actually, about that one is 1837 is the year Tiffany & Co. was founded, which is a nice little Easter egg. Coca-Cola Red is 484C. UPS Brown that they use on all their trucks is Pantone 462C. And then a little bit more recently, Charlie XCX's Brat Green from her album was officially specified as Pantone 3507C. And there's been a little bit of talk about trademarking it. These companies or these entities legally own these colors within their product categories. If you tried to launch a jewelry brand that used that same Tiffany blue for your packaging, logo, or website colors, Tiffany could and likely would sue you for trademark infringement. That's the power of owning a color. And Pantone numbers are the language of those trademarks. The legal trademark documents will specify Pantone 1837C because that's a precise, standardized, universally understood reference. You can't trademark a nice light blue or a robin's egg blue. You need a scientific level of precision. So while the Adobe situation is annoying and has changed how we access Pantone colors, Pantone itself isn't going anywhere, and it's still the standard for brand identity work, packaging, and any situation where color, precision, and legal protection matter. I still pay my $180 per year, like many other designers do now, on top of my annual $2,100 for the latest edition of Pantone's reference library chips every other year. All that said, you still need to know about it, even if you're not paying for that subscription. Now let's talk about the difference between spot colors and process colors, because this is something you're going to encounter constantly in print work, and understanding the difference will save you a lot of headaches and a lot of money. Process colors are CMYK. That four-color printing that we talked about earlier, that's what's happening here. The printer uses cyan, magenta, yellow, and black inks, and they layer them in tiny little dots to create the illusion of different colors. It's kind of like pointillism, but much smaller if you've ever studied that painting technique. Your eye will blend all of those dots together and it perceives a full range of colors. Process printing is super, super cost effective for full color images and photography because you're only using 4 inks to create millions and millions of colors. But it has that limited, much smaller CMYK gamut that we talked about earlier. And colors can shift slightly between print runs because you're mixing inks on the press in real time. There's not a great deal of microscopically precise control with that. Spot colors, on the other hand, like Pantone colors, are premixed inks that are applied in single layers in a single pass. Each spot color is its own separate ink, and it requires its own separate printing plate as well. So if you're using 2 spot colors in your design, even if they're super similar, that's 2 separate printing plates. They're 3 spot colors, that's 3 plates. There is a way to sort of skirt around this by using something called tints. You can tint back a color, and it will effectively give this effect of screening a color back. So you ultimately end up with less ink on the page, and you only have to use 1 plate because you're still using the same color, but it results in a slightly lighter option. But each additional spot color essentially adds cost because you're adding complexity to the print job. But here's what you get for that extra cost. Spot colors are consistent. You get the exact same color every single time because it's the same pre-mixed ink formula. Spot colors can also achieve colors that are completely outside the CMYK gamut. You can print metallics like gold and silver. You can hit some of those really bright neons or even light pastels that you can actually get really specific, and you can get a lot of saturated colors that CMYK just isn't capable of touching. Oftentimes, spot colors are used for things like logos, brand colors, and packaging, where color accuracy is absolutely non-negotiable. If you're printing a Coca-Cola can, you're using a spot color for sure for that red, not CMYK, because that red has to be exact. Every single can everywhere in the world has to look the same. But you wouldn't use spot colors for something like printing a photograph. You actually wouldn't even be able to do that. Or really, you probably also wouldn't use it for something like a headline in a magazine. So just some use cases for that here. So when should you use process colors versus spot colors? Just to give you a quick guide, use process when you are working with full color photography or complex gradients and images, things that have tons of colors and subtle transitions. CMYK process color is perfect for that. Also use process when you're on a tight budget. 4-color printing is a standard, very economical way to print. Most commercial printers can do it. It's not all that expensive, and it works great for most applications. You can use spot color when brand color accuracy is absolutely critical, and when you need that color to be exact and consistent across every single print run. Use spot when you need colors outside the CMYK gamut, like metallics or bright saturated colors. And then use spot when you're working with limited color designs. If your design only has 2 or 3 colors in total, like a logo with a brand color and maybe a black, spot colors can actually be more economical than full CMYK because you're only paying for those 2 or 3 plates instead of 4. Although some printers can have as many as like up to 8 or even 13 different plates of ink on one print run, meaning that there is a physical limit of 8 to 13 colors at any given time on that press. And typically, you might also need to add one or two passes of varnish on there as well that you might need to account for. Most importantly, before you even think about designing something with a spot color, verify that the printer you are going to use is actually capable of printing spot colors. Oftentimes, when you start using spot colors, you're going to be printing very large quantities, 5,000 plus individual pieces of something. And you will need to use an offset press rather than a digital press. So just a pro tip when you're working in Adobe apps as well, when you create a color swatch, then double click on that swatch. There's a little checkbox that says global. Check that box. What that does is it makes that swatch a global color, which means that if you ever need to change that color later, you can just double click that swatch again, change it once, and every single instance of that color in your design updates automatically. You don't have to go hunting for it if you've used that color 47 times throughout a 20% or a 20-page document. So it'll just save a lot of time and frustration, frankly. And in this industry, the more efficient we can make our work, the more money we can ultimately make. All right, we're back. Sorry about that. As you can tell, it is morning. It got a little late last night, so I had to cut the video. I was also losing my voice, so I apologize. Good moment for me to mention that these videos can get long and technical. I don't expect you to like sit and watch these in one sitting. Try to break them up throughout the day. That way you can kind of really capture the information. Usually like 40 minutes is a good time to take a break. 40 minutes, watch the lecture, take a 1 hour break, come back and watch 40 more minutes. You get the picture. Anyhow, let me share my screen again, and then we'll get started again. This is where we left off. We left off with spot and process colors. We got all the way through that section. So moving on from there, let me get this all set up again. There we go. Okay. Now we can sort of talk about what are called CXF colors. And I brought this one up a couple of times as well. So let's talk about CXF. It stands for Color Exchange Format. This is newer than Pantone, and it's becoming increasingly more important, especially if you're working in industries like packaging or manufacturing. CXF is a standardized data format for exchanging color information across a supply chain. It basically is just a digital file that stores complete color specifications, including what's called spectral data, which goes much further than RGB or CMYK values. It's actually more akin to something like a lab value. Spectral data is the raw physical wavelengths of light. It stores information about how the color reflects light across the entire visible spectrum, even more than lab colors do. So it's way more detailed. It's way more accurate than simply just specifying a color. CXF files work with color measurement devices like spectrophotometers and colorimeters, which are tools that can actually measure color objectively. And it does that by analyzing how light reflects off the surface. So in other words, it's measuring the luminance of that color. So instead of just eyeballing it and saying, yeah, that looks close enough, you can actually measure the color scientifically and get objective data as to whether that color is accurate or not. And the reason that this matters is because it really dramatically reduces color variation in production, particularly in print. Um, let's say that you're a company manufacturing a product in 5 different factories across 3 different countries. If you send them all a CXF file, they're all going to be working from the exact same color data. They can measure their output against that data and use that to ensure consistency across the product lines. And that's not an uncommon area to be in. It's really critical for packaging. We were using it at PetSmart. You can also use it for things like textiles and plastics, basically any physical product where color consistency matters, but you're not necessarily printing with traditional inks at this point. I think that's something to point out. The inks are in this the inks are much more like Pantones, but they're much, much, much more tightly controlled. CXF is especially useful when Pantone just isn't precise enough, or when you're working with materials that don't have Pantone equivalents. So, for example, there's no Pantone swatch for specific shades of blue on, let's say, a specific metal, right? They have Pantone colors for plastics. They're a little bit limited, but like a specific color of metal or printed onto a metal, they don't really have those. So you can create a CXF file for that in order to offset the color cast from the metal. It gets really technical, but it is kind of the future of color management in manufacturing, and it's definitely worth knowing about, even if you may never end up using it. From there we go. From there, we can sort of talk about the International Color Consortium, or ICC profiles, which are one of those sort of behind the scenes things that makes color management possible. An ICC profile tells software how a specific device ultimately should interpret color. Every single monitor, every single printer, every camera, every scanner, they all see color a little bit differently. They all have different hardware, different calibrations, and different characteristics. ICC profiles sort of map those device-specific colors to a standard color, or at least a standard color space, so that when you move a file from one device to another, that software can then translate the colors more appropriately and more accurately. Without ICC profiles, colors would sort of shift pretty widely. They would kind of be a little unruly from one device to the next. Every time you opened a file, you would probably, or at least every time you opened a file on a different computer or sent something to a different printer, it would look completely different. So some of the more common profiles that you'll probably encounter are sRGB. That's sort of the standard profile for use on the web, and for most consumer monitors as well. If you're designing something for the web, you'll end up using sRGB. Adobe RGB, on the other hand, is maybe not much, but it is a larger gamut. It is a statistically significant larger gamut. It can reproduce more colors than sRGB, in other words. So that's kind of how you can look at gamuts. They're kind of bigger or smaller, and the bigger the gamut, the more colors they're able to produce. And you probably, Adobe RGB is really the industry standard for professional design and photography work. There's actually a gamut a little bit larger than that. I'll get to that in a minute, that we use for photography, but Adobe RGB is probably what you're going to end up using if you're doing some high-end print work or photo editing. You'll probably want to be in Adobe RGB, or perhaps even the next one, which is ProPhoto RGB. And that one has the widest available RGB color gamut. It is absolutely massive. It is mostly used by professional photographers who want to preserve as much color data as possible. It actually extends outside of the typical spectrum for what RGB displays can actually produce. Uh, it's kind of a strange color spectrum, but it's really good if you're trying to retain all the color data. You really probably only need to be using this if you're shooting on a camera that is capable of producing about 16 bits of color. Uh, but even some cameras that shoot 14-bit, they are going to automatically export, or they will typically be able to capture only as high as Adobe RGB, but when you go to edit, you might use ProPhoto RGB because those adjustments that you make within Adobe could extend you further into something like 16-bit color, where ProPhoto RGB does become a little bit helpful. And then there are various CMYK profiles that are specific to different printers and paper types, and a profile for high-end offset press printing on something like coated paper is going to be a little bit different from a profile for a desktop inkjet printer on matte paper that we would use at home. There are profiles that account for differences as minute as a different paper stock. And if you've calibrated your monitor, which we talked about a little bit earlier, then you've essentially created a custom display profile for that specific monitor under your specific lighting conditions. And ICC profiles are how we are able to get an idea for what the color is going to look like when it does come off our screens and out into some sort of physical medium. Now, you know a little bit about how technical color can be, hopefully. I think it's important for us to do some housekeeping on some of the common problems and solutions when you're working with color. This is not a comprehensive list by any means, but it is a good start. So let's start with one of the most frustrating things in design. And I'm going to take this one real slow for you. Every single monitor displays color differently. Yay! And I do mean every monitor. Even two identical monitors from the same manufacturer bought on the same day, two serial numbers apart from each other, will display colors at least slightly differently coming right out of the box. So all the stuff that I told you about color consistency, you can toss that right out of the window for digital design, technically. Don't quite do that. But there's a reason why this happens. There's actually a lot of reasons why this happens. Monitors use different panel technologies. Some use something called IPS, others use OLED displays. There are even some called VA displays and TN displays, and each one has very different color characteristics. And factory calibration can vary pretty widely between manufacturers, and even different price points can have additional or less calibration. A $2,000 professional display may be calibrated way more carefully than a $200 budget monitor. And sometimes that's not the case at all. Sometimes you can buy a very expensive monitor and it can have very trash color. So beyond that, you even have variables that are outside of the control of the calibration. Users are able to adjust brightness and color settings all on their own. Some people crank the brightness all the way up. Some people like it dim. Some people even mess with the color temperature and make it more warm. Really, digital displays are kind of the Wild West. And then even beyond that, ambient lighting in the room ultimately affects how you perceive colors and how those colors are perceived even on screen. And we learned about that already a little bit. If you're in a room with warm light, warm yellow lighting, colors on your screen will look different than if you are in a room with cooler blue lighting. So if that wasn't enough, all monitors can also drift out of calibration over time as the backlights age. A monitor that was perfectly calibrated a year ago probably is not perfectly calibrated anymore. At the end of the day, you can't really control how your clients or your users see your work. You can't control whether they're viewing your design on a cheap laptop in a bright coffee shop or on a calibrated display in a very controlled environment. That's not something that you have power over. But what you can control is your work environment. You can control calibrating your own monitor about every month or two. And you do that using hardwares like it's called an X-Rite Color Monkey or a Data Color Spider. Those are just two brands that do largely the same thing. Personally, I prefer X-Rites. There's a whole system for that within the photo video world. So I kind of stick to that. And it also works within print as well because you have color proofers and spectrometers that are all made by X-Rite. So that's my preference. But this just works to ensure that you at least are working with accurate colors, even if you can't guarantee what everyone else sees. Try as much as you can to neutralize the lighting in your workspace. Ideally, that would be about 5,000 Kelvin, which are roughly the daylight balanced light bulbs that you can buy at the hardware store, rather than the cool white bulbs or the warm white bulbs that you could buy. These are not perfect solutions, but they are way better than just working on an uncalibrated monitor or making color decisions under inaccurate lighting. And I do mean every monitor. This affects every single monitor in the world, even if you paid. Apple's got like $5,000 monitors these days, so even they are still affected. And then we have print color issues, which are a whole different beast. Some colors are just inherently harder to reproduce accurately in print. And it's really helpful to know which ones you can make smarter design decisions about up front. Purples are notorious. They are so hard to hit consistently. They often shift to being muddy or slightly too pink or too blue on the press. I can't tell you how many times I've been in press checks watching purple colors shift all over the place from one print to the next. We actually had this exact problem when I was working at PetSmart. I'll tell you a little bit about that in a bit. But bright greens can also be a little bit of a problem because the gamut of most pigmented inks, since they are inherently subtracting light, cannot often hit those bright, vibrant, sometimes almost neon greens that you can see on screen. They always print a little bit duller than we typically hope. This actually becomes a huge issue in some of my landscape photography work, where sometimes in real life you have a moss in a photo of a waterfall or something like that that's almost glowing and just a beautiful neon green. And because the camera can photograph in RGB, it can really pick up those green colors because those bright greens work natively with the camera sensor color space. And most camera sensors have more green. They use a slightly different array. It's called a Bayer array, which oftentimes leans a little bit more green. So it's picking up those greens really well. But when you go to print those out, those greens can very easily get crushed or kind of yucky. So I just have to watch out for that in my histograms in Photoshop and look for those out of gamut warnings that I told you about earlier. And then even some deep blues can appear a little too cyan. They can end up looking more like turquoise than navy. We actually run into that with our brand colors at Renneker Studio because we have a deep navy that we use. Flesh tones are a nightmare to work with sometimes. They're incredibly sensitive to even small shifts because human eyes are actually even better at sensing shifts in skin tone than we are other colors. Because when skin tones look wrong, we're sort of hardwired for it because that's how many of us are able to tell if someone is well or potentially sick and contagious. It literally is our psychology using color to keep us safe by tapping into our flight or fight response. So it gets a little tricky. But the reason that this happens is partly because of the gamut limitations in print. Some colors just can't be reproduced accurately with pigmented inks, even if you're working with Pantones or CXF colors. But it's also ink mixing on press simply isn't a perfect thing. It's very chemical and mechanical. The inks can and often do interact with each other in some slightly unpredictable ways, which can cause some of those shifts. And it's important to remember that inks are a physical substance with their own properties. And the color of paper can also affect the final result, where ink on really bright white paper looks a little different than something like a slightly cream colored paper, or even a gray paper, or recycled papers that might be different from one dye lot to the next. You're not going to eliminate all variation at all, ever. Sometimes the physics of a color just don't cooperate. And in those situations, you're sometimes best off selecting a different color if that's within your realm to do. And then speaking of paper, substrates matter way more than most people realize. The material that you're printing on has an absolutely huge effect and huge impact on the final output of the color. Coated papers have smooth, sealed surfaces where the inks sort of sit on top of the paper, unlike what are called uncoated papers, where the inks sink into the literal fibers of the paper. And on uncoated papers, you can get a much brighter, more saturated look to your colors because the light reflects cleanly off the surface. Whereas uncoated paper is more porous and it has tiny little fibers in it. And the ink then soaks into those fibers, which makes colors appear more muted or softer and generally a little less vibrant as well. It's not worse, it's just different. I use both all the time in my work. It has just a different aesthetic. And that's something that you can leverage as a designer if you're sending something out to print. So it's not a better or worse than the other. Tinted papers, however, things like creams, grays, browns, other colored stocks will shift the colors of the inks that you're putting on them because you're essentially printing on top of a colored background. If you print cyan or on something like a cream paper, it's going to give that cyan a more greenish look because you're essentially printing on top of a slightly yellowish background, and yellow plus blue gets you to green. How color works in the subtractive color space. So it's important for you to know how those colors are going to interact because the colors are literally going to mix as they're being laid down. There are some specialty substrates, things like plastics, foils, fabrics. You can even print on wood and metal. Each one has completely different properties and requires a little bit of different handling from one to the next. And printing directly onto something like a metallic foil creates totally different color effects than printing onto a matte piece of paper. The foil physically reflects light differently. The ink interacts differently with the substrate, and the substrate may have its own tinting, much like colored paper stocks. And there can be a whole lot to account for in that. And none of this is uncommon. You probably encounter a package every single day that has some sort of printed foil on it. Probably even look around and find something. Yeah, I would have to probably go into the pantry or something like that, but it's out there. Trust me, you don't have to look all that far. This is exactly why press checks exist. Every high stakes project that I do, you bet I'll be traveling to that press check. A press check is essentially where you have to actually go to the print facility where they're running your job. And usually press checks are very early in the morning, 3, 4 a.m. That way the pressmen have the rest of the day after your press check to actually run the job and once they've dialed everything in. And you look at the sheets coming off the press on the actual substrate with the actual inks under actual lighting conditions so that you can make tweaks. And we do this because that's really the only way to see what the final product is going to look like. It is expensive, it takes time, but for projects where color accuracy is mission critical, like in packaging or branding collateral, it's 100% worth it. All right, we're going to get a little nerdy here. Let me sip some coffee. This stuff gets technical. I don't even expect you to be able to use this. However, it is good to know that it's there. We're going to talk a little bit about delta E. This is a metric that measures the visible difference between two colors. It is a way of quantifying color accuracy objectively instead of just saying, yeah, that looks about right. The way this works is that you take two colors and capture their lab values, usually with something called a colorimeter or even a spectrophotometer. And if you remember lab color spaces from earlier in this section, L stands for lightness, and then the A channel represents the green to red color axis, and the B represents the blue to yellow color axis. You measure both colors in lab, and then you run those values through a mathematical formula called the delta E 2000, which accounts for how humans actually perceive color differences. And it sort of gives you a single number that represents how different those two colors are. The scale works a little bit like this, where a delta E, if it's less than 1.0, that those two colors are largely imperceptible to each other, to the human eye. Humans can't really detect the difference in anything less than 1.0. That's actually extremely hard to achieve. But it is possible. The colors will look identical. A delta E between 1.0 and 2.0 is slightly perceptible with extremely close observation, likely something only a very experienced designer is going to be able to notice. And if you're looking carefully side by side, you might notice a very slight difference. A delta E between 2.0 and 3.5 is perceptible at a glance. You don't really have to be looking for it. You'll probably notice this. And then a delta E between 3.5 and 5.0 is a very clear difference. Anybody looking at that would see these colors and they would be able to tell that they are different. Anything greater than a 5.0 means people will largely perceive those as separate colors. Effectively, it would be like looking at the difference between red and orange. Delta E measurements give you an objective, measurable way to talk about color accuracy as it is coming off the press. Instead of arguing with a printer about whether a color is close enough, you can say, we are getting a delta E of 3.2 and our tolerance is a delta E of less than 2.0. So this is out of spec and we need to dial it in. Being able to do this and have that conversation removes subjectivity. It's either right or wrong, period. And I get this in class from students all the time where they're like, what do you mean I did all the right stuff? And it's like, okay, but if you're not hitting the right numbers, it's wrong, right? Now, you might never personally calculate delta E values in your career. That's something reserved specifically for print work. That's fine, but most designers actually will never use this, but you will hear about delta E in print production conversations and specifically color quality control conversations. So it's important to understand what people are talking about and what the tolerances mean. Here are just some industry standard tolerances. Brand critical packaging like Coca-Cola cans, Tiffany boxes, those usually aim for a delta E of less than 1.0. It's extremely precise. It's very hard to achieve. Only certain printers are capable of even doing that. You're basically looking for imperceptible differences. That's an extremely tight tolerance. It is extremely expensive to maintain, but for those brands, inconsistency could result in millions of dollars in lost sales. You don't want to be the designer that causes that. So just trust me on that one. If that's your tolerance, you need to hit it. High quality print production, typically you can aim for a target of less than 2.0. That's typically good enough. This is what we were aiming for when we were working at PetSmart, typically. This is a good balance between quality and practicality that most high-end commercial printers are capable of hitting. Commercial print for things like business cards, mailers, or stationery, those are a little bit more forgiving. Usually a delta E of less than 3.0 is absolutely acceptable. It's still good. There's going to be a little bit of wiggle room there, especially to account for the sheer volume that's typically involved with a production of collateral like this. So we can account for those slight offsets. And just to give you a real story from when I was working at PetSmart, we had a sub brand called All Living Things that was for small animals, reptiles, and birds. And the brand color was sort of a mid-tone purple, but we had it specified as a CXF color. Should be really simple. It was actually a nightmare. We worked with incredibly experienced, high quality printers, and we maintained really tight tolerances of less than 2.0, which is about as tight as you can get for something like that. And we still couldn't hit it consistently. One press would run it and it would shift a little bit towards pink, and then we would run it on another press and it would shift towards blue. And occasionally we would get it right. But after a lot of frustration over a couple of years, and just a lot of wasted money trying to get the stupid purple to work, we finally figured out what was happening. And it was the particular shade of purple that we had chosen was at the very edge of the printer's capable gamut, particularly on the white laminated corrugate that we tended to use for this product. So the color was in this sort of unstable region of the gamut where small variations in ink density or slight changes in the conditions on the press or just a little bit of humidity in the air, just a variation, which some of our packages were printed in Taiwan, some of them were printed in China, some of them were printed domestically. So you have varying print conditions and varying humidity that would cause it to shift in one direction or the other, a little more pink or a little more blue. And the color itself was actually the problem. So the takeaway here is not that it's just that all colors aren't created equal when it comes to reproducibility. Some colors are easy to hit and maintain. Others might be working against physics in order to lay down on the page. And in those cases, it's just typically the best move to try to get a redesign put into place so that we can just stop trying to defy the laws of physics, because believe me, you will lose every time with color. This one here is a little bit of a stretch, but overprint versus knockout is just an understanding that will save you some really expensive mistakes, particularly in print. These terms describe how inks layer when you're printing. And this is one of those things where the default settings can bite you a little bit if you don't know what you're doing. Knockout is the default in most Adobe applications, particularly those used for print outputs like Illustrator and InDesign. And when you place one object on top of another, the term knockout means that the top object essentially creates an invisible hole when you place one object on top of another. The term knockout means the top object essentially creates an invisible hole in that bottom layer. It knocks out or removes the bottom layer, or the bottom color, I should say. The inks or the layers don't actually mix in that scenario. It's cutting a shape out of a piece of paper by almost like using a cookie cutter. Top shape, cuts through the background. It's completely removed. In print, that prevents those inks from mixing and creating unexpected colors. Overprint is the other option. This is not the default. You have to go in and turn this on intentionally, though there are very few, but very specific instances where you may want to use that. And overprint means the top object prints directly on top of the bottom color. And the inks are physically laid down one after the other. If you have a shape on the bottom and another on the top, and both are different colors, the bottom ink will lay down first, and then the top ink will go directly on top of the last. If you've screened that overlay, you can even combine the two colors in sort of new ways to create an entirely new color just from mixing the two inks together. And those are typically the technique that we would use in something like a risograph. But you can use knockouts and overprints in a lot of offset printing types. Red printed over yellow creates orange, blue over yellow creates green. And this can be useful for specific effects or specific scenarios, but it can also create some really big problems if you don't know that it's happening. So if you don't pay attention to the overprint settings, you can get some unintended color mixing and colors combining in ways that you really didn't plan for, or you might not get the color effect that you were looking for or it could just pull everything out of registration as well, where the colors don't line up perfectly on press, and you end up with these little white halos or gaps between colors on the page. There's a lot of things that can go wrong just by not paying attention to overprints and knockouts. So a little bit of a story about why me learning about overprints and knockouts the hard way. When I was designing packaging for Arcadia Trail at PetSmart, we were putting we were printing directly onto some really thick brown, craft brown chipboard is what it's called. That's the material in this photo. We had varying thicknesses depending on the product type and how much it weighed. And that brown substrate would completely shift our brand colors. Oranges and blues would look really muddy or dull because it was a brown colored substrate and it was on an uncoated surface. So the solution that we came up with was using our layering strategically and then also using overprints in order to get the color fidelity back. On the first layer, we placed a white ink, and we set that to knockout because there was really nothing behind it other than the artboard. And we printed that just directly onto the brown chipboard. On layer 2, we essentially duplicated layer 1, but we set the white ink of that layer to overprint, and we printed over top of that first white layer, directly on top of it. So 2 white layers at this point, coming off the press, 2 stations of white. Then on layer 3, we placed all of our other CXF brand colors. So this might be multiple stations, but these are sort of the blue that you see here, the orange, all of that those are just additional separate colors that are going on top of the whites. And this was called laying hits of white. We did this because one layer of white wasn't opaque enough on such a dark brown substrate to give us that neutral base for some of the other colors to sit on. And getting a neutral base from 2 hits of white also gave us a sort of sealing effect on this uncoated chipboard. And it sort of created something for the colored ink to sit on top of rather than soaking into the chipboard, which also gave us much better color accuracy and improved the vibrancy of the colors. And without this, the brown would show through and sort of shift all the colors. And while the results of approaching it this way didn't give us perfect color fidelity, it did significantly offset the shading caused by the brown chipboard and gave us much more of a natural foundation to print over top of. And this is why understanding overprint versus knockout matters in production. So to avoid those type of printing disasters, use overprint preview. In Illustrator or InDesign, you can get to that just by going to View and then Overprint Preview. Or you can use the keyboard shortcut Command Option Shift Y or Control Alt Shift Y, something like that. Which is it's kind of a weird combination. You have to press all of them at one time. But do this before you export files every single time, because when you turn on Overprint Preview, you see exactly how the inks will interact on the press. What you see on your screen is what you're going to get. Always, and I mean always, check Overprint Preview before you send files to production. Make it part of your pre-flight checklist for sending things to print. I've seen so many disasters from this, believe it or not. One of the common ones is setting black text to overprint on a colored background. That happens a lot. The designer might think that black text would knock out the background and be crisp. But instead, the black ink that was printed directly on top of the colored inks ended up mixing. That happens a lot. So instead of a pure black text, you end up with a muddy brownish text that just is hard to read and looks terrible. That's a really expensive mistake, especially if you just sent 10,000 brochures to print and no one catches it before you did that. That can be a costly mistake that could cost your job. Or another one that I've seen is someone maybe set a thin stroke to overprint, and you get this unexpected color shift in all of your outlines on your design. Those are all preventable mistakes, and you have to check overprint preview before you do it. It takes 2 seconds. That's it. It will save you so much money and headaches. And then last topic for this section is color accessibility. This is important, and it's something that a lot of designers still don't think about nearly enough, particularly in print. I think we've got a lot of digital designers that are thinking about this, but approximately 8% of men and 0.5% of women have some form of color blindness. And if you do the math, obviously that's very disproportionate to men, but in a room of 100 people, about 4 or 5 of them will have some sort of color vision deficiency. And that's not a tiny edge case. That's a significant portion of your audience. If you're taking this class online, there's probably a chance there's at least one person in this room or in this class who has some sort of color deficiency. And the most common types are called I always say these a little funky, so forgive me if I get them wrong, but it's deuteranomaly and protoanomaly. Both of these are affecting red-green color perceptions, and people with these conditions have a pretty significant to moderate difficulty in distinguishing between reds and greens. They can see color, but certain color combinations look very similar or identical to them. Tritonomaly, which affects blue, yellow color perceptions, is a much rarer condition. But importantly, lean in, come on, listen close. Never, ever, 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 ever rely on color alone to convey color or any sort of information. If you are designing a dashboard and you use green to mean good and red to mean bad, someone with a red-green color blindness cannot tell the difference between those. They are looking at your interface or your print, and they have zero idea which metrics are good and which ones are bad. That is a failure of design. And what should you do instead, though? Use color and something else. Color plus icons, or color plus text labels, color plus patterns, or some sort of difference that they can understand the information from. Also, ensure that sufficient contrast exists between things like your text and your backgrounds. The Web Content Accessibility Guidelines is actually a good standard for both digital applications as well as print applications. Um, there are some specifically listed contrast ratios that you should always try to hit. I think it's 3.5 to 1 or something like that, or 4.5 to 1 for large text. Double check. There's some different qualifications. There are two standards, and there are free tools and online tools where you can check colors to see if they meet those two standards. One is AA and one is AAA. And test your designs with colorblind simulators as well. And better yet, test it with colorblind users. I think every designer should have a library of a few people that they know are colorblind they can test their designs with. There are browser extensions for this. You have online tools, even features built into some design softwares now that show you what your design will look like to people with different types of color vision deficiencies. Use them. It takes 5 minutes, and I've personally had it reveal some major usability errors that you would never have caught otherwise. And this applies to both print and digital applications. I will tell you right now, employers are looking for this in your portfolios because companies are getting sued up and down for not creating accessible designs. It is a huge liability for a lot of companies right now. And accessible design is not just a nice to have. It's not optional. It is just doing good design work. When you make your work accessible, you're making it better for everyone. You are communicating more clearly, more effectively, and to a wider audience. So you're actually expanding the audience that business or that brand could have. Now, we covered a lot of very technical information so far. I promise not every lecture is going to be this way, but I wanted to get you all up to speed with some of this more technical stuff before we get into the more theoretical stuff. And at this point, you might be feeling a little bit stressed, perhaps a bit confused. Some of you may be asking, is this even the right field? Did I do something wrong? Where did I go astray? Am I in the right class? I encourage you that you are, in fact, in the right place. Everything will be okay. That said, let's talk a little bit about imposter syndrome. Because imposter syndrome affects 7 in 10 people at some point in their lives. And for some of you, that point in your life could very well be right now. That is okay. People at any stage in their careers can experience imposter syndromes. It happens a lot during promotions, when you're getting a new degree, large professional changes. All of those things can worsen the feelings of imposter syndrome. And imposter syndrome looks different for everyone, but these are just some of the ways that it can sort of manifest. Here's a few tips to just help you overcome that imposter syndrome. I kindly remind beginners that senior designers might also suffer from imposter syndrome. I know I have suffered from it at various stages, and I'm probably not done with it. People learn things on the job in every career, including the design industry. Doing it, though, is the best way to learn design. That's kind of the bottom line there. And when you feel like a phony, I think it's important to remember that empathy, not just talent, makes you a designer. After all, unsuccessful designs just help create better items that satisfy your customers' needs. It's just one iteration that you've done, and you're going to do several. I also think it's important to not be afraid to inquire about how you can better satisfy your customers or end users' needs and their expectations. Set clear goals. You will know how to improve without pressuring yourself into being perfect. And feedback is always your friend. Get feedback early and often, particularly from peers and from actual users of your products. I am happy to give you feedback, and you will get plenty of feedback from me. But I would so much value someone saying, I found this feedback from my users. What do I do with it? That's way more valuable than anything that I'm ever going to tell you. And then something important that I think I should point out here is that making assumptions about others' knowledge also doesn't help you grow. Mastery comes from being observant and asking questions and learning from your shortcomings. And then just using all of that to help yourself improve every single day, even if it's just a small amount. I usually say 1% better every day. If you can get 1% better at something every single day, you will be the expert at something at some point. I am still learning. I am still getting 1% better every day. And when you can add to your knowledge toolbox from things that others are giving you, you're sort of starting to tap into the natural superpowers of design, which is this sense of community. Design is a very communal industry. And that leads me to this. In this class, and really the rest of your graduate career, and even outside of your graduate career, as you guys are all getting jobs and starting to work in the industries, I want you specifically in this class to start working with this technique now by leveraging each other. I want you all to be networking with each other, use each other for feedback and to get insights from each other. Share knowledge with each other, use the Slack channels, support each other. That isn't optional in this class. It is an expectation in this class. We are going to be covering a lot of things. I want you all to support each other. If you see someone ask a question and I'm, or whoever your professor is the first one to answer it, you all are doing it wrong. You all should be jumping in and supporting each other and helping each other through the program. This is not a competition. There is enough space for everyone in this industry. And I want you all to be successful. If you guys start creating that network together, you all are going to cross the finish line together. And it's going to be an amazing feeling. So I encourage you all to do that. I know this lecture was really long. I do apologize. I promise not all of my lectures are going to be this way. But I do hope that you enjoyed it. I hope you learned a lot of very technical stuff. Take good notes, support each other. If you guys have confusions, start a discussion in the Slack channel. Carry on the conversation after this lecture. I want to see that. I hope you guys enjoyed it. Have a wonderful day.